And here we go. We have liftoff. Propulsion continues to be normal.
RCPA chamber pressure looks good.
Following up. Roger, planet.
Water towers fly! Yes!
Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange!
Orange 25! Oh my god! Oh my god!
Decollage. What is it? Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If it was methane, it would be igniting in the flare, correct?
Yikes. Keep red. Sure. We don't need any more of these.
Welcome, everybody. We're going to have a fun time watching this 5-segment SRB light up. And if anyone's new to these events, you're going to be in for a nice surprise because these are extremely impressive tests. And this one is a test for the future. This is called BOLE. This is DM1 test of BOLE, which is for Block 2 SLS, the booster Obsolescence and Life Extension 5-segment booster. So it's a brand new design for the future, providing SLS gets as far as the Block 2, of course. But either ways, this is going to be fired within an hour, and it's going to be for 2 minutes. And if you are only used to static fires of the likes of Starship, get ready for a surprise because solids, they make a difference. So this is going to be a fun live stream. Thankfully, joining us on commentary is Sawyer. Hello, Sawyer.
Hello, Chris. It is always great to talk about something that is, I guess in this case, shuttle adjacent, since they're moving away from the actual shuttle hardware. But happy to talk about it. And there you go. Shuttle mentioned in the first 3 minutes.
You did very well, Sawyer. I'm very proud of you. Also, we've got a team out there actually in Utah. For NSF, we've got Philip Sloss, we've got Justin Davenport, and this view is provided to you by Jack. Jack's out there. I wonder if Jack can just say a quick hello to chat, because I know it's Utah, and I know the internet's not amazing, but there he is.
A quick hello to chat. No, it's a beautiful morning, and all of the noise has not started up here yet with the music and the speakers and everything. But this is a big deal. This is an interesting motor. It's carbon composite case. It's very different from the current flying boosters with the shuttle heritage. Obviously, there's a bunch of stuff similar, but this is going to be interesting. I'm excited. I don't know if you can tell. I've had a lot of caffeine, but this is going to be a good one, Chris.
I absolutely agree. I mean, again, I prefaced it at the start of this live stream by people who may not be used to this, because we have a lot of people who obviously found our channel via Starship and via SpaceX and via other things, but they may have not been aware that we've been covering these kind of technology since the start, since we started on this stuff, because of the shuttle program. And Sawyer, you mentioned it at the start. It's not technically the same. Oh, I'm so used to this SRB that we saw flying with Space Shuttle as a 4-segment booster. This is a 5-segment booster for SLS, but it has been taken on an evolution, shall we say. Maybe you want to talk about that a little bit.
Yeah, definitely. So there was the original shuttle boosters that we're kind of used to, and we've seen versions of them that have been modified for the early Artemis missions. They still have even slightly more updated ones going through Block 1B for SLS. But the main thing is they want to try and kind of upgrade them, make them a little more modern, and give them more oomph, for lack of a better way to put it. So basically, they've done a bit of a redesign on it. So as was pointed out a little bit there by Jack, brand new composite materials with special joint fiber technology. So basically, it's going to be 30% lighter. There's also new mechanisms to help improve joint seals, which, if you know, SRB boosters can be an issue when you've got segmented. They've upgraded the actual material that they're using inside. The propellant is very different from the shuttle one, which was more of a proprietary one. This is something that's a lot more of an industry standard, the hydroxyl terminated polybutadiene. I just wanted to also get to say that. They are changing the nozzle so that it's also lighter. It can handle the extra heat and actually will adapt better to the new to the new launch mounts as they work on the second tower. So lots of cool upgrades, and also finally electric thrust vector control, so less hydraulics.
Indeed,
I
yeah.
can chime in really quick. Sorry. The nozzle, they walked us through the factory yesterday. Unfortunately, there was no photos allowed. They said they're going to release some photos. There was a photographer with us, but the nozzle Sawyer from the BOLE booster versus the standard SLS SRB, way bigger. Like it is completely different. And in fact, I think the entire casing is like 2 inches wider in diameter. It's quite stark. Like this is completely different.
Yeah, it's fascinating because I remember lots of released photographs of the previous SRB hydraulic system for the TVC, and it's all in the actual outskirt of the booster, and it is a lot of hardware with this massive, massive arm, which basically did what you imagine TVC does, which redirects the nozzle in direction of travel, which they want to do. That's how they steer. And it was something people may not realize that during the space shuttle program, when you watch the launch, I'm sure the majority of people in chat right now will have seen a shuttle launch video. When it rolls off the pad, that is the SRBs basically just rolling the vehicle. That is the steering that's involved there. It is the main part. And then when they got to second stage, it was the RS-25s with their TVCs doing the keyhole to orbit steering. So it's a fascinating thing to see the difference that they're going to show, hopefully in these release photographs that come. There's a great graphic of the BOLE booster on screen there. Thanks to James producing it. I never thank the producers. And I was joking that I wouldn't do it, but I was going to make a point of doing it. But thank you to Jay for producing this stream as well, because we're going to get to see things like this. I will also note that we will take your questions, as always, on our live stream. So if you do have a question that you want to ask us, do at NASASpaceflight, followed by a question. It goes into a panel. We'll be able to answer the best we can. I've got one from Kevin Michael Reed to start with straight away. It is a fun one because people do ask this every time I've shown a video of an SRB test in Utah. The SRB is sideways. Is it going to spin the Earth faster than normal? The irony, Sawyer, is this is actually pretty much buried down into big, massive girders into the Earth. So technically, it's strapped to the side of a mountain, isn't it?
It really is. I don't think this is enough to change the rotation of the Earth anything close to noticeable, or anything basically above zero. But it is a giant concrete block built into a mountain that it is placed on top of, and you see all of the connections to it there on the screen, holding it in place. So, I mean, if you're having a bad day, you can blame it on the BOLE test and claim that it changed the spin of the Earth, but no, it's not.
Pauline Brooke
I
asks a
love
good
that question.
Pauline Brooke asks a good question, which always, it kind of like when I saw the explanation of what BOLE stands for, I was thinking, why are they using that name? So why do you think they're using the word obsolescence in the name of the BOLE?
Because they're finally getting rid of all of the shuttle hardware, which that was part of the deal with SLS, as we know, was to try and use existing shuttle hardware that we already had to, try and make things go faster and easier. Obviously, that may not have been the case. So the plan is to kind of move away from shuttle and some of the sort of obsolete technologies that were on it. Again, it had its own sort of propellant that it used. The casting of the propellant was totally different. The engine was different. You had the thicker walls. You had a lot more complicated issues with the seals and the connections. This is a way to finally improve it, and on top of that, add an ability to carry much more mass into orbit. This thing is adding so much more specific impulse, so much more thrust, that I believe you can carry at least an additional 3 metric tons to orbit.
Thanks also to B, who's done the first to super chat in this stream, and it is an important thing because we spent quite a bit of money to send people out there to provide these unique views of this test, which we're always going to do because I think this is a really cool thing to be able to show live. We have followed the SRB testing all the way through its program, but we've actually done a few live streams in the olden days, but this is the first one in a while where we get to cover it live with our own cameras as well, thanks to Jack being out there. So thank you, B, just spreading the love, and Moon. I think that is definitely one for you, Jack. Yeah.
I love that because the BOLE boosters will be used for Artemis. What is it, 9+, if I'm not mistaken?
Yep.
So if these things fly at some point, we'll be well into the moon era. So that is a very apt chant. You can see a firing here from the previous time we were able to do this, and I just can't reiterate enough. Thank you for the super chat there, B. The only reason we can do this is because y'all support what we do. I did get to take some photos today. Yesterday, again, no photos, but today, when we were setting up remotes, I took a whole bunch of photos of the BOLE booster, and those will be up for members later. So if you are a member, look out for those. It's been such a scramble this morning, I haven't had time to edit them yet, but hey, we're doing what we can. So thank you all so much for the support. It's such a privilege and an honor to be here. This place is solid rocket booster heaven, Chris. I'm in solid rocket booster heaven.
You sound as excited as I am, actually. I do remember on previous tests that sometimes, and I don't know if they'll do it this time round, they'll bring on a commentator who doesn't sound like he's a rocket engineer. They sound like they brought him in from some studio, who goes things like, T plus 10 seconds. The booster is still firing. T plus 20 seconds. 44 million horsepower. It's brilliant. I'm actually looking forward to if they do that again. It did add a lot to it, I must admit. I'm not one for those non-technical commentaries, but he was actually brilliant. So during the actual firing itself, which would be 2 minutes long, I probably will not say a word and just see what comes through, because either ways we'll get the sound of the booster firing. Relevant to that point, Mythos Technologies asking, this one for you, Sawyer, do we know the average thrust output of this new SRB?
The average thrust output on this one, yes. So, let me pull up my sheet here with the data on it. There we go. So the original ones, I believe, had 3.6 million pounds of thrust going back to the shuttle days. This one, oh geez, hang on, come back to me. I'm drawing a. Why did my brain just stop?
Fine, because actually that was kind of the irony of my point of what the commentator said. He refused to mention the actual thrust levels. He just went 44 million horsepower, and anyone who follows rockets knows that horsepower is not often used to project what the power of the thrust is. So there's differences in the way that works on the actual numbers they provide for this. But again, I want to go back also while Sorry's looking for some facts and figures from. Oh, there we go.
It was just under 4 million pounds of thrust.
4 million pounds of thrust. One SRB as well, which is impressive. As you know, I'm not going to surprise anybody to let them know that there's two SRBs that launch with SLS. Unlike silly rocket Ares, which was going to be a single SRB with a liquid upper stage engine, which was never going to work out well. And they found that out. There was going to be thrust oscillation issues, which I was told by Ares engineers later on that something that was overplayed in the way they had to mitigate that with extra dampeners, which then added extra mass, which then took away the capability from Orion because it couldn't lift as much as Orion. It was a bit of a problem, that rocket. That's why we do joke it was a silly rocket, because what turned out to be Ares 5 has become pretty much what SLS has become. It's more of the design that they've tried and tested with the SRBs, having two of them on the side of an external tank, in this case a core stage for SLS. But yes, this is actually an Ares question in there. If I'm going to try and bring it unrelated, is there anyone trying Ares-like launch system? Well, that's an irony. Do you remember Liberty? Sawyer, the Liberty rocket that they were going to try and ATK were going to try and use as a rival for medium launch technology. It was going to launch from 39B, I believe.
Yeah, it was also the single stick solid configuration, kind of like this, and then you had the capsule also on the top with the round. It was a weird looking idea. It almost looked like a copy and paste of Ares 1 in a way.
Yep. Severin asks, is there any way the SRBs can gimbal? Yes, that is the nozzle. That's what we're talking about with the way that they direct the nozzle via TVC, which is how they steer in the direction. It's something I'm trying to bring back my knowledge on watching SRBs return, because the difference with SLS, and I know this is, I'm kind of pausing as I'm saying this, because the original plan was to bring the SRBs back like they did the shuttle program under a parachute, but they deleted that. I can't remember Sawyer, if they still use the parachutes on the SLS SRBs, even if they aren't going to reuse the boosters, did they actually just drop them dead weight into the ocean now?
Yeah, they got rid of that as a way to save mass. So you had the 5 segments and then the top part, basically the cone, for lack of a better way to put it here without getting too technical, that had the parachute and everything stuffed inside of it, no longer does. It's more hollow so that they can save mass. So it's
Yep.
completely gone. It's gonna hit when it hits, and it's gonna be a bad day to be a fish.
T-minus 44 minutes to go to this test. These things don't tend to hold for any, there won't be any range violations. There won't be any wayward boats in Utah, so that's one thing. But this should be on time, pending any technical issues. But they will do polling for the test firing, as you'd expect. And everything's okay. We've got 44 minutes to go until we see this thing light up. And again, I am super excited. People may be wondering why I'm super excited, because I've seen plenty of these before. And it's the first time for this design of booster, of SRB. Thank you to Martin Horman, who's become a Red Team member, upgraded to Red Team. Very much appreciated. I will say, as Red Team level, it's not just your name in green in chat. I know a lot of YouTube channels just make you a different color in the username on your chat, but you actually do get extra content. Do please check out the membership area in the community area of our channel, because you will find there is daily content in there, because I upload it, so I know that's in there. And including will be a selection from Jack's photographs as well, because that is one of the areas we upload it. We have Jim asking, why isn't SLS expert Phillips lost on the live stream? He's there, but we're trying to get him on comms. It is quite hard to get local comms from this middle of Utah area. So if we can get him on, we will get him on, but he is there. So we definitely hope he will be able to chime in at some point. Mike Alpha Tango.
He's in the briefing right now. When he's done with the briefing, he's going to come out, and if he can get on comms, he'll let y'all know what he learned in the briefing.
Very good. Mike Alpha Tango Sierra, Matt, one of our regulars, has gifted 10 Red Team memberships. So speaking of Red Team memberships, that's 10 people who just got a membership for free. Please say thank you to Matt, because that is so generous of Matt to do that. Very much appreciated as well. Space Max 7110. My word, these usernames are all one massive list of letters and numbers. That's why I sometimes babble them. But Space Max 710 has said, after years of watching these events online, I finally get to watch one of these events in person, and my home state of Utah. Do say in chat if you're from Utah, because this is your big thing for the rocket industry. This is where you get really involved as a state. We all know that SLS likes spreading its technology around the states as a flex, shall we say. Whereas some companies, like commercial companies like SpaceX, tend to like to be very much in-house in very specific areas. I'm trying to think of the actual states mainly involved with SLS. It'd be Utah for the SRBs. It'd be Alabama and Martha and Marshall. You got KSC for the launch site. Am I missing a state that's deeply involved with SLS? Sawyer.
I mean, technically, all 50 of them are contributing something. But yeah, you've got Alabama, you've got Mississippi, which is doing some more of the testing here in Utah, here in Florida. You've got the core coming from Louisiana for the center core, just like they did with the shuttle core tanks. California, I believe the upper stage is Colorado. Trying to think if there's anywhere else that's providing physical hardware, at least.
I know AMRA do the panels for the core stage in California, so that's another example as well. It's something that SLS program would promote, say, look at all these states, and you can imagine why that's the case, because that gives them some guarantees. Because although I don't like the term jobs program, they do provide a lot of high-skilled jobs. It's not necessarily a negative, that, is it? Let's face it. It's people being employed working on rockets in high-skilled jobs across states rather than one area in question. It's a different methodology of how you run a program, and it is a NASA program, as you can imagine, but they have lots of contractors involved. I kind of prefacing this by going on to these questions here about how Northrop Grumman could bring this maybe up sooner than Artemis 9. It's the whole Block 2 question, Sawyer. We've got Block 1 SLS right now. They're going to go to Block 1B with the EUS upper stage. Block 2 is the final iteration of SLS, and that is mainly for the Mars missions. What's your take on all of this? Because I personally would have started off on Block 1B from the start. That's what I would have gone with. 105 metric ton capability, lots of capability with the upper stage as well. Block 2, maybe for the Mars missions. I mean, that is a long way off. I don't think we're going to see Block 2 flying until the late 2030s, maybe 2040s. I mean, it's a big ask. What's your entire take on all of this evolution from 1 to 1B to 2?
Oh boy. I mean, I get it. They wanted to test something to begin with, but it would have been nice just to start with 1B. But at the same time, it's taken as long as it has just to get to Block 1. So I'm glad we were at least able to fly a vehicle so far and have a second one that is stacked and is being worked on actively inside the VAB down at KSC in Florida. What I'm worried about is all of this testing and things that we're seeing now is so far down the line that I worry that it might not see the light of day. It would have been great to start with something massive like this. Hopefully, we'll get to see 1B, which is set to start, I believe, with Artemis 4, if I remember rightly. So, yeah. I hope they keep SLS going so that we can see Block 2, but it's a shame that we're even having to wait so long for 1B.
Yeah, my personal thought is that we may get to 1B, but I don't think SLS is going to get to Artemis 9. I don't think so right now. Again, there are valid questions. People saying, well, hang on a minute. Everyone's saying everything should go to Starship. Look what's happening with that test program right now. Let's face it, they are struggling with Starship right now as a Block 2. I think that will improve when they go to the next evolution of Starship, especially with lessons learned and all these issues they've had this year with the Block 2 will be very beneficial for long-term program. That's why it's called a test program. Even if this test has an issue, it's a test program. They find things on the ground rather than flying. And that is the important thing. That's where I go back to Ship 36. I'm going down a rabbit hole a little bit here, sorry, but Ship 36 blowing up on the test stand is a lot better than it blowing up on a full stack on the launch site or during launch itself. So that is little positives where they can find issues during testing that will play out long term, will allow them to launch with some extra confidence on finding the faults before they have a major issue later on in the program when it's operational, for example. These boosters here, I've got a Smile asking me, is this for Artemis 2? No, it's not. It's actually for Artemis 9. That's why we're talking about its future, because this is a booster that will debut as a Block 2 SLS on Artemis 9. That's a long time away, but they do tend to do these testings. I remember the testing before SLS launched, the DM1, DM2 tests or QM1, QM2 tests for Artemis. They were many years ago, many years ago before Arianespace. So this makes sense for a timing because they are trying to get this new technology tested. Do we know, Sawyer? I don't know if it's been publicized, so you might not know. Do we know how many of these tests do you think they'll do before it actually does fly on a Block 2? Maybe 3 or 4?
It's at least 2, DM1 and DM2. DM2 will have a lot of the upgrades that DM1 doesn't have. So we know for sure at least 2. The other thing that we know is, remember how you were just saying that, well, at least it's not like a launch with range violations. They typically don't delay. We have a delay. It's been reported that there is a delay. They have not said the exact reason why yet, and they have not announced an updated T0 for the firing. But that is per Jack, who's out there, that there is a new T0 forthcoming.
Interesting. That usually isn't the case with these SB tests. Jack, yes?
Yeah, originally the test was supposed to be, I think, at 1 or 2 p.m. Mountain Time, and they moved it forward for conditioning purposes. So they keep these boosters at different temperatures depending on what they're trying to test. There's like a low temperature test, a high temperature test, and a standard temperature test. This one, I believe, is a lower temperature test. They wanted it like at 60 degrees or something like that. And so because we're in the desert and it's hot, they moved the test forward to 11 a.m. Mountain, and now maybe it's not hot enough. Maybe it's been too mild of a morning. I'm completely speculating here, but now they're moving the test back again. As soon as I get a new time, I'll let you know. But Who knows? Maybe it's like temperature considerations, something like that. But as soon as I get any info, I will let you know. In fact, actually, I just heard I am now hearing 11:30, so just a 30-minute delay, no big deal.
Big deal. 30 minutes we can deal with. It's not like your average Starlink launch. I think the other Starlink recently, that was lots of delays on it. But that's technically for Florida weather, because Florida weather, sorry, is terrible compared to Utah, correct? Yes? No?
Yeah, yeah.
I've been unfair.
Thanks. There's no snow here, at least, as opposed to Utah. But yeah, so as Jack was pointing out, they do want to do the test at 60 degrees Fahrenheit, so it's about 16 degrees Celsius. So not sure if that's the reason why, but as pointed out, yes, there's this is kind of ambient-ish temperature. They do tend to do ones with higher and or lower temps, so we'll see as they continue with the testing regime.
Let's talk about casings, because I have several questions here that I will try and consolidate into one reference about how it works with the casings, because as you remember during the space shuttle program, the SRBs were technically called reusable. Now, it doesn't necessarily mean, as Rocket Girl's asking here, once all the rocket inside is burned off, I assume fuel, can they fill them back up and fire them again, or do they suffer too much damage? And I've got questions about casings and such. So let's talk about the casings, because the reusability of the shuttle SRBs was not a case of them being pulled back to port, which they were, by Liberty Star and Freedom Star, brought back into port as complete boosters, then put onto the dock, but then not refueled. They then took them apart. They literally took them apart. The only thing that was reused was the individual casings that got reflown. So let's talk about that, Sawyer, because the claim that the SRBs were reusable wasn't technically the case of a full four segment in the case of shuttle booster being returned to Utah, filled back up with solid propellant, and then sent back out again, was it?
No, it definitely wasn't. As you pointed out, there was the casings that were used, which they then had to work everything on the inside. If you've ever seen the nozzles afterwards, especially, those things get absolutely roasted. So if you look at ever video or pictures of it being towed back in by Liberty Star and Freedom Star, as I saw in person, it is amazing that anything seemed like it would fly again with that. But they do that. They had to refurbish it, retest everything, make sure the strength was there, work on the seals for everything. It was a lot to get it back together again. But they were able to have, segments that were used multiple flights. Kind of like getting into the range of Falcon booster reuse.
Oh, look at that, Sawyer. Memories. We had the two. I think both of those ships are still in operation. I think for the US Coast Guard, aren't they? I know Liberty Star and Freedom Star were the two ships they used to recover the boosters, but I have so many stories about these ships. One thing that I didn't realize until learning more about shuttle was RTLS abort, return to launch site abort, which was very much a case of unlikely to return back to the landing site, but it was called that, would involve a contingency that seemed more hopeful, where the crew would bail out over the SRB recovery boats. So these boats could have been involved in an RTLS abort where they then fished out the astronauts from the ocean. So I'm sure you've got 101 stories, sir, about these boats, so I'm going to let you just talk.
I don't have many personal stories myself of the boats, other than I'm looking through my photos to see the ones I took after STS-135, where they brought them back in through the locks one last time. But yeah, they'll typically splash down. They would have a diver that would then go into the water and basically pop a cork in it for a visual, put something in the bottom of the actual nozzle to kind of seal it off, and then they would have it go horizontal, tug it alongside the boat, and bring it back in. And again, it just went right through the normal locks that you would see at Port Canaveral area. It was really cool.
That's right. I remember the plug. They had a diver who would go down under the water surface to plug the aft of the SRB. So obviously, because they wanted to float the thing, and that was before the Frogman on the Dragon. The Frogman on the Dragon became famous for his little extrovert departure from the Dragon before it was lifted onto the nest. That was our version during shuttle. We never saw it live, unfortunately, unlike Dragons. We never saw it live. But they had a frogman who would jump off the recovery boats, with the plug, and then would literally like almost like there we go. That's a better picture. You can see the aft end of the booster there. That was plugged. And the irony there is, and I wonder if this is the case with this booster, I assume so, there will be a plug that is on the aft end of this booster that gets fired away. There are slow motion clips. I should have prepared all these for you, Jay, because I've got so much footage I could have shown you. The slow motion of the SRB firing, the first thing you'll see is a bunch of debris being thrown away from the aft before the fire of the actual ignition comes through. And that is the way they plug it. And that's an environmental seal. So that is a cool thing. I'm just getting reminded of things that I wouldn't have thought about until these questions come in. So thank you for your questions. Keep them coming in because we'll answer as many as we can, especially with the extra time we've got.
Hey, Chris.
Yes.
Fun fact, a lot of solid motors have those plugs. I have some foam from, I think, a gem off of an Atlas from Vandenberg. And I have some foam from a Delta as well. And you mentioned a slow-mo camera and slow-mo video of that plug getting ejected. Well, if the slow-mo gods shine on us today, I have 2 separate slow-mo cameras set up at the remote site, basically like feet away from the booster. And hopefully we'll get some slow-mo shots of the nozzle and that plug getting ejected. There's also a mirror. They put a mirror right in front of the nozzle so that they can point a high-speed camera into the mirror and get a shot of that plug like getting ejected. And then the mirror, of course, gets obliterated. So hopefully we'll have some shots of that from my remote cameras if everything works. That'll be really nifty. Everybody collectively cross your fingers.
I will endeavor to find some of that slow motion video. I know it was from NASA, and I know it is from way in history. So we're not talking about 1080p here. We're talking about back in the olden days of Real Player. Anyone in chat remember Real Player? That was it was amazing at the time because it was the first time your home computer could show live videos and like things like that. It was like, oh, this is the future now. We're living in the future now. But yeah, the quality today would not really stack up that well, but I will find some things. We've got plenty of time. We've still got over an hour now because of the delay, so we've got plenty of time to show lots of footage. I will try and steal it out of L2 and give it to Jay to show on screen. Talking about reuse, technically, is there any way, the question is here, is there any way that if these SRBs don't go flying on SLS, they could be reused on any other rockets? Well, 2 parts of this before I give it to you, Sawyer, is they've not got a factory full of SRBs. They make them pretty much on order. I doubt they've even got one in the factory in Utah, which is just standing around waiting for a launch. 2, I can't imagine any rocket that I'm thinking of that could make any use of these boosters, unless I'm going crazy.
I mean, I guess it's also worth pointing out that technically a lot of the elements that are on this particular booster were taken from a different booster that was meant to kind of be a different rocket. So the Omega rocket, if anyone remembers that was being developed back in the day, I believe if that was Northrop Grumman that worked on that. So that's when they started testing out all these new ideas of, hey, what if we do electric thrust vector control? What if now we do a different type of fiber on the casing? So there's a lot of commonalities between that. They actually did a bunch of tests already of the different composite segments for Omega. So in a way, this is kind of being reused for a different rocket.
Yeah, absolutely. It's fascinating because we do have a lot of history with these boosters and the potential rockets they could have flown with. I keep bringing up Liberty. I actually like Liberty, which is very SLS, very Aries. That's the word I'm looking for. Very Aries-like. You see, my brain automatically stops me from saying the word Aries because it's a silly rocket.
It knows.
Yeah, it is. But it was almost like how it should have been, if I can say that without being any derogatory towards the Aries people, because they did the best they could with it. And I will admit to the Aries fan club that Aries 1X, while very silly at staging, it was an impressive launch. It's such a tall vehicle. I was surprised by how tall it was because it launched from what was still a shuttle pad at the time. And it was impressive. I was like, this is a tall rocket, and this is pretty good. And first stage was excellent. The dummy upper stage let it down somewhat. It was a pretty much awful staging, and basically the cable did not detach, so it got pulled back towards itself. It was all kind of like a little bit silly. The booster had a parachute failure during landing, so it got a massive dent in the side of it. Oh, there was so many things going on there. But yeah, I do have more questions about this future of SLS, and I'm going to ask chat. I'm going to get chat to be interactive with this because I do like to do those things, but it gets interactive. Do we think? I might make a poll out of this as well. Do we think SLS will be still around by the time it gets to Artemis 9, which is this booster is used for? Sawyer, I'm going to give you the first go at this while I do a poll.
Oh, I hope so. I'll say that. Do I think so? No. Do I hope so? Yes. Because even if you go back to Apollo, you had Apollo 11, 12, 13, which didn't land, and then they canceled it after 17. So they had those couple flights, and let's assume that we continue with the timeline as is. First landing on Artemis 3, 3, 4, 5, 6, 7, 8. Even if it goes the way of Apollo, there's your 6 landings, and then 9 doesn't happen. I also wouldn't be surprised if it comes to a point where they get Block 1B up and running and say, you know what? This is going to be the final design. Let's not actually upgrade and let's not make all the crazy changes to make a Block 2, and they just end on 1B.
Yeah, I'm also forgetting Omega. We had Liberty and Omega. They were the two variants that followed on from Ares. They were commercial rockets, by the way. They weren't NASA rockets as such. Ares was a NASA rocket. So Omega was the last version of what they were looking to propose, which was a version of Liberty itself. Again, all very much similar rockets. But yeah, I'd be doing disservice not mentioning Omega. I thought that was a good rocket as well. That was more like it. Ares felt a little bit relevant. I think it was a 2011, was it? Authorization Act, which basically said we can't continue with this rocket. Let's go with an SLS derivative version of it at least. And that's where SLS came from. But before that, it was trade studies at the end of the space shuttle program, what was going to come next. And they thought, well, the fastest way to do it would be to use shuttle heritage hardware. And that's what they came up with. That's where Ares came from, because they thought, hang on a minute, we've got the boosters. We know what we're doing with that. But that can work from the launch pads we've got still. That can work as well. It just didn't work out. It was unfortunate, but that's what happens with rockets. They're not easy. We have more questions here about the BOLE booster and its appearance. Mathematics, if I'm pronouncing that correctly, asks, I have a question. With the BOLE boosters, new carbon fiber construction, will the booster be grey colour on launch day? I'm assuming they're going to paint it. It'd be very unlike
They are.
NASA. Oh, hello, Jack. Were you going to chime in about the colour of the booster on launch day when it's figured?
Yeah, sorry. Yeah, they do plan on painting it. They deliberately left the DM1 BOLE booster unpainted, just for reasons, including that it's distinctive. So yeah, the actual flight hardware, and I believe the next one as well to be tested. I'm not positive on that though. Will be painted.
I have a grenade to throw into chat here with a question. How big a chance is that NASA's budget cuts ESA? NASA's budget cuts, ESA becomes the leading space agency. I'm going to say, even as a European, I can't see that ever happening. The budget for ESA is very well spent. They do a lot with the budget, but it is minute, even to the worst case NASA budget scenario. So I can't see that. I can't see any agency becoming a bigger deal than NASA. Even with the cuts, it's still massively more than what ESA gets for its yearly budget. I will give praise to ESA because they do a lot with it. So that's one thing you can say ESA does very well. But they do not get anything close to the budget, even in the worst case scenarios, that NASA gets. Would you agree with that, Sawyer?
I would agree. I mean, they do amazing science. If you've seen any of our European series that we do where we talk to some of the manufacturers and the rocket companies and all the people that are out in Europe doing such great work, there is a lot of spaceflight hardware and a lot of spaceflight science coming out of ESA and Europe and all of those companies. Even now, NASA kind of doesn't hold the same prestige that it used to. It's not the NASA of your generation and my generation. Now the companies are the SpaceXs, the Blue Origins, even more so than NASA. So it's going to be harder for ESA to jump ahead of NASA when NASA's even struggling to jump ahead of NASA.
I could answer this, but I will say this is definitely one for Sawyer to give his take on, because I think my answer may have confused Gabriel a little bit, and I won't blame him, because that's the kind of thing I tend to do, is confuse the audience. I'm confused. How did the SRBs of the space shuttle get reused? I thought the SRB was recovered and then a new one was stacked in a VAB. So again, it's more about the casing side. Maybe you want to just explain the life pattern of an SRB.
Do you want to take that one?
I did take that one earlier, but if you want to give your version of it.
Um, let's see. I'm trying to think of the best way to describe the reuse of it. I mean, they were more refurbished than reused, I think is kind of the best way to describe it.
Yeah.
As you pointed out, we're not talking that they would just bring it back like Falcon 9, do a quick inspection, and throw it back out there. Each of the segments would then have to be taken apart. They would be cleaned out. They would have to be check the casing, make sure there was no dents, no cracks, no dings, things like that. Check the integrity of it. Then they would have to work on putting it back together. And the other thing is that when they put them back together, it wasn't like you were talking the exact same segments were being put together with the same ones that flew on that flight. So you could have boosters that flew on STS-127, ones that flew on STS-101, and ones that flew on STS-70, all in the same flight. So it was kind of just as they were working through them, whichever one was next and ready in the lineup as they did their refurbishment is the one that they would repair, restack, and put it all together. So yeah, basically, once you crash your car and you get the dings and dents out, you put the SRB back together.
Talk about the area we're in here. Brian asked the question about, is this the Dugway Proving Grounds in Utah? I would not know if I've never used that name before. Jack, what area of Utah is this? Does Dugway ring any bells?
It's actually Promontory, Utah, of Golden Spike fame. So if you are a train nerd like me and many other rocket nerds, for some reason, there's a lot of overlap there. If you are a train nerd, then you know when they were building the Transcontinental Railway in the United States, when the two halves met, they were joined with a golden spike. There's a national monument there. That's like right up the road from here. So this is just a facility that Northrop Grumman Space Systems has here in Promontory, Utah. It was formerly Orbital ATK, and then before that it was ATK, and then before that it was Morton Thiokol, and before that it was Thiokol. It's a long running facility that has existed here, and now is currently run by Northrop, who has acquired the most recent version of the company. So not Dugway. It's just Northrop Grumman's Promontory, Utah rocket motor construction and test facility.
Clinton, maybe one of the Aries fan club. There is an Aries fan club. There are dozens of them in the Aries fan club. Who asks, would it be possible to use existing technology for a modified version of Aries 1 or something like that if the Artemis program was cancelled? I'm going to say there'd be probably no need for it, because if Artemis gets cancelled, then that's quite a big an issue, because Artemis isn't just SLS. Artemis involves also Starship and Blue Origin. It's including the lunar landers. It's a whole big program. It's all about the moon and Mars. It covers everything, not just SLS. So let's take SLS being cancelled. What happens in that scenario? Chat, get involved in this, because it's a hot potato. Sawyer, let's say the powers that be say, okay, we've decided, hopefully they won't be that happy. Okay, we've decided SLS is cancelled. No more SLS, no more launches. That's SLS gone. The natural evolution would be to put everything into Starship, which is risky, but natural. Can you imagine anything else getting involved? Would Starship take over the role that SLS was going to provide? I think I may have just lost Sawyer there.
Sorry about that. Can you hear me now?
I can hear you now.
All right. I think there would have to be another player. I mean, we talk about it all the time, the dissimilar, redundant architecture. if something happens to it, then there's really nothing right now launching crew. I know that's going to become the case here anyway, as they work on retiring Crew Dragon eventually. But in terms of the private sector, at least right now, you have the public and the private. You have Orion, you have Dragon. I'm sure there'll be other companies that would work on some form of crew transport in the future. Uh, but I think there would have to be another player besides just Starship.
There we go. Very good. If you're just joining us, this is now 44 minutes again to the ignition of the BOLE booster, which is a 5-segment experimental booster test for what will be debuting on the Block 2 SLS for Artemis 9. If we get that far, but that's what this test is for. It has been delayed 30 minutes, which is where you may have come back and checked in and thinking, hang on a minute, this clock has not come down that much. It's because it delayed 30 minutes, but that's fine. It's 43 minutes now until ignition of this booster. And trust me, I've preempted it. It's a crisp promise. This is exciting because I've seen many SRB tests before in Utah, and they are very, very, very powerful. Super powerful. I do like this question from Hans Simon, who asks, will the sand turn into glass behind the boosters? I think it does. Something in my mind tells me that there are post-firing photographs of the area after the booster that's been firing in, because you'll see the dust all rise up. But for some reason, I remember glass. Am I going crazy, Sawyer? Does that ring any bells with you?
You are not going crazy. I remember there being glass as well when you're superheating sand, so it's going to turn into glass.
Very cool. Does each propellant, this is from Jason B, does each segment have its own propellant load pattern, or are they identical?
That's actually a really good question, and it's a good way to kind of talk about how they actually throttle an SRB, a solid rocket booster here. So basically, like they did with Shuttle, they do the same thing kind of with SLS, except 5 segments instead of 4. It all comes down to the grain of the propellant that they use and the shape in which they load it in. Sometimes it's more cylindrical, sometimes it's more of like a star pattern. They have these different kind of patterns that they use. So that way, as they're going through the launch, as it burns down, when they need to throttle down, well, you just change the way the propellant is shaped or the way that it's packed in, and then it will actually throttle it down and then be able to throttle it back up after it goes through what the expected max Q time is. So it's not like it's one giant exact same pattern all the way through the whole thing. There are little deviations and changes to adjust for the thrust, that rhymes, as you go. So basically, they are going to each be different all the way through all 5 segments as they adjust for what they need for that part of the flight.
That was one of the things they showed us yesterday was the tool that they use and the casting pits and everything. I believe BOLE has a 10-pointed star in some portions, and that is to, like you said, so taper the thrust profile. Really neat.
Thank you to RC Horseman, one of our absolute regulars, gifted 10 Red Team memberships. So if you do get a Red Team membership in chat, please say thank you to RC Horseman, because it will tell you as well. If you're in chat right now and you see I've been gifted a Red Team membership by RC Horseman, just say thank you in chat. It's for free. It's for a month. You do not get recharged. It's something where you can just basically use it for a month and it'll just drop off if you don't renew. We've got a hot mic somewhere. I don't know where that is. But thank you to RC Horseman. Very much appreciated. Clinton, would it be possible to use existing technology for a modified version? Oh, we've just done that one. Ignore that. Kelsey asks, that sounds like Philip Sloss joining us. Hello, Philip. No, maybe not. Many private launch companies do not use SRBs. Is it because they're too expensive, Sawyer?
I mean, not necessarily price. I mean, part of it, I'm sure, would be price in there, but one of the biggest concerns that comes down to it is that solids shake quite a bunch. I'm sure you've seen it with all the shuttle launch video, the people inside rocking and rolling with it. They're quite powerful. They do add quite a bunch of shake, which can be an issue for certain satellites if not controlled exactly right. And yes, most of the time they're casted, like the GEM 63s are cast as one big single segment rather than the multiple segments of these, and then disposed of afterwards. So Part of it is kind of price, but a lot of it is going to be the fact that they're tricky to work with. They're dangerous in some ways, and they're a lot of weight. And once you turn it on, you can't turn it back off.
Very good. I'm wondering if Philip is joined. I keep hearing. I keep hearing. We can hear you now, Philip. Hello, Philip. Philip Sloss is joining us. Thank you for joining us, Philip. You're out there. Looking forward to this test.
Yeah, we're waiting to. I guess we're waiting to hear if they've got got all the T's crossed and I's dotted, or vice versa. But I think the last we'd heard was 11:30. So we're just we can see you guys have the shot. That's basically what we're looking at here at the T-97 test stand out there in the distance. So they just they couple of the program managers, one for Northrop Grumman and one for SLS booster office, just gave us a little briefing a few minutes ago. So um, I don't know if Jack got a chance to pass it along, but the action time for the booster, which is basically from ignition to burnout, is supposed to be 127 seconds. So it's very much in line with which they designed it to do. Um, they gave us a handout that shows the thrust trace of it, but it's designed to basically burn for the same amount of time as the 5 segment SLS boosters, but it's you're giving the vehicle a significant amount of extra impulse, and so that's they're still talking about. The design goal for this is to add 5 metric tons of performance on top of the Block 1B vehicle. So Block 1B is supposed to add between 10 and 11 of co-manifest performance. So Orion's 27 metric tons, and that's going to always be there. And so if adding all of that up, if this flies, you would get basically a 15 metric ton class spacecraft that could fly along with Orion to in theory gateway. But yeah, so we're just waiting to see. We're just waiting to hear if they're still on schedule now for 11:30.
So, what was the reason for the slip of 30 minutes? Did they actually give any detailed reasons why they were holding for 30 minutes?
Well, what we heard was euphemistically referred to as paperwork. So, I guess there must have been some things on the checklist that they needed to go back and verify. So, um, I don't know if you guys. Well, no, you guys don't have the NASA stream yet. I think they were gonna start feeding, but we can see what they're doing here. There were At the time they announced that, there were still a whole bunch of personnel out at the stand around the booster. So it looks like it looks a little quieter now. So hopefully they got a lot of that done, and they're just evacuating and getting outside the danger area.
Yeah, it's for people wondering, Philip is actually out there at the test site in the middle of Utah. That's why the communications aren't coming through on a perfectly good microphone like mine. This is really kind of like live reporting from the test site. So that's a question which answers Vince's point there in chat. I did you anything else of interest being mentioned at the briefing? Because you were at the briefing, Philip. So any other tidbits we got there from the Northrop Grumman people?
I'm trying to think of what else. I mean, the only it's these are actually the gentlemen that I interviewed. It was almost exactly 4 years ago, and so there are a few changes. So the old sort of roadmap for this was they were going to fire this motor, development motor one, and then they were going to do the preliminary design review off of that, based off the data for that. Then they were going to fire 2 more development motors, 2 and 3. Then the critical design review, and then 2 qualification motors would basically get them ready to fly at that point. QM1, QM2. What they said in the briefing was, number one, they've already completed the preliminary design review before this test, and then based on experience from like the Omega, they've worked with this a lot. Based on the Omega um, development and other development of technology out here, they are planning to only do 2 development motors and leaving an option open for a third. But the idea would be DM1, DM2, and then QM1, QM2 to get to the basically to get to their design certification review. And then, who knows when exactly that's going to be. They did not say that. And, there's going to be there's all the issues with the budget probably could factor into this, not just this year, but the coming years. But so the point there being, this design might be ready. Design might be ready around the turn of around the beginning of the next decade, but it's very unlikely that SLS will have consumed all of the existing 5-segment case hardware by then. So we'll just have to play it. I assume they're just going to have to play it by ear. That was one of the questions I did want to ask them: is are they considering doing an early cutover of this design? If it, they haven't even tested this yet, but assuming that this goes well and they're happy with what they're seeing, would they consider cutting over to this? Because it would, as I was saying, it would give them an additional. A 10 metric ton spacecraft versus a 15 metric ton spacecraft is a pretty big deal, either from logistics or any type of a spacecraft that Orion could take to Gateway.
Yep, some fun questions in chat. One is, has one of these boosters ever broken loose during testing? No. If it did, it would be on to the next state by the time it stopped firing. It would not be a good thing. That's sorry, I'll bring you back in again. We did talk about this earlier in the show, but a lot of people are joining, obviously, as we get close to the ignition. How is it anchored into the test stand? Because it is literally anchored.
Yes, it is anchored onto a giant block of concrete, and that concrete is poured into the mountain that it is located on in Promontory, Utah. So you see, obviously, the clamps and everything on top, kind of holding it from that angle, but that is bolted into concrete, which is bolted into the mountain, which means this booster isn't going anywhere.
Yep. A technical question from Magnum. Maybe Philip wants to take this if Philip's okay talking still. How are the SRB segments securely mated to each other, being in a carbon composites? Are they still in segments?
Yes, it's the segments were as opposed to the Omega first stage. That vehicle was designed with 4 segments in the first stage, but they have a lot more flexibility with the composite case winding equipment that they have here. So they wanted to minimize the processing changes that the folks at Exploration Ground Systems folks at Kennedy Space Center would need to do when they do that cutover. So these segments are there are 5 segments. They're basically the same length as the existing 5-segment boosters. The diameter is very slightly larger. That was something that I found out when I got here. So the existing case segments, the Shuttle Heritage, were 146.5 inches in diameter. These are actually, I guess technically it was 146.4 inches in diameter, and these ones are 148.5 inches in diameter. But it really does retain very much the same sort of form and fit as the boosters. And in terms of the field joints and the factory joints, I don't think these segments have a factory joint. So the composite cases are wound, that you would, so for the shuttle 5-segment boosters, those are, each segment consists of 2 cylinders, and those are bolted together as a factory joint and before they even put the propellant in. And then you have the field joints between all 5 segments. For this one, the composite cases, there are actually steel rings on either end. The forward segment and the aft segment are special cases. So the forward segment has a forward dome and the aft segment has an aft dome and the nozzle. But then on the other end of those those segments, and then on both ends of all the other ones, they have steel for the field joins. And so it was actually interesting yesterday on the tour that Jack and Justin and I were on. We got to see what that composite to steel joint looks like. It's just like with the boosters when they mate them at the cape vertically. I can't remember exactly how many pins, but they use pins. The joints are pinned together, and they do the same thing with this. It's a similar type of joint design as well. So the composite case is the I'm mixing the tang and clevis up again, but the I think it's the tang end. So and then the steel has a clevis joint, and so then those are also pinned. Although it's looked like a whole bunch more pins between the composite case and the steel rings on the end. But yeah, there's the steel joints will be similar in terms of how they're put together at the cape.
A random question in chat, which is not related to this test, but is what we do, is we cover things about the Electron launch coverage. We only really tend to do coverage of where we got cameras. Now, if there's some big major space docking going on, obviously we don't have a camera in space, but we'll cover it if it's a major event. But most of the ground events, such as tests and launches, we will do live streams with our own cameras. We'll mix in the official coverage as well. If we were to do a live stream of the upcoming Electron launch, we'll be just talking over the Rocket Lab coverage, which is silly because everyone commentators as well. So we don't do those things. We don't restream that way. We always tend to do things we have a camera at. Now, obviously, Rocket Lab, when they do Wallops launches, that's become something where we can have a camera there. So that tends to be ones we do. So hopefully that answers your question. We don't just restream everything. We actually, as in this case right now, you're looking at a view provided by Jack's camera. Jack is literally looking at that view. That is our view. That is our test. Now, when NASA provide their camera views close to the actual test itself, we'll chime those in as well, so you'll have the best of both worlds. That's how we do things. Now, back onto the booster itself. Matrix asks, does this booster have an FTS during testing? That's an interesting question. So, Sawyer, an FTS on this booster, one, how would they use it in what scenario? And do we know if it does actually have one? Because once this thing lights up, it can't be shut down unless it's going to go boom or it's going to use up all its propellant.
I don't know the exact answer, but I don't believe that they would. Part of it is, if you just think of the name there, FTS, Flight Termination System, this will not be in flight. As you pointed out, if anything happens, it's already securely mounted to the ground. It would likely kind of blow up on its own if needed. Plus, one of the reasons they try to use the FTS only in flight and not on the ground is that you're not actively destroying hardware that's already mounted there and that's on the ground if you don't have to. So I don't believe that they would have an FTS active on a ground test like this.
Very good. Now, as we get close to this launch, we're going to have a little change out of commentary where I depart, and we're joined by the wonderful Alex. Hello, Alex.
Hello, Chris. I see you guys are having fun here with a test, and so I was like, I also want to have fun too.
Very good. Sawyer is now going to take over hosting, if that's okay. Hopefully Sawyer knows about this before I just throw him under the bus and say, Sawyer, it's over to you.
Wait, what? I had no idea. Oh, no. Yeah, no, I've got you, Chris.
Thank you. Bye-bye, guys.
Thank you, Chris Bergen, NASA Spaceflight official, for joining us for the first part of the stream here. If you are just joining and checking in again, this is a live look in Promontory, Utah, where Northrop Grumman tests the solid rocket boosters, and this is going to be one of the BOLE boosters, as we've learned that it's pronounced. So basically, that is one of the tests of an upgraded solid rocket booster that will be used for SLS Block 2 and is expected to begin starting for Artemis 9. Alex, I mean, I know we were asking this a bit earlier, but I want your opinion on it. Do you think we'll ever see one of these actually fly?
Oh dear. I wish to see that, because it will mean, that the Artemis program has become so much efficient and everything, that, they've decided to keep it around, right? and gotten all the way to Artemis 9. But yeah, I mean, I was sort of discussing this a few days ago that it could be the Ares 1X of Artemis, right? Because by the time Ares 1X was tested, it was like, it was already sort of assumed that Constellation was going to be thrown out the door essentially. And so right now it's like, will Artemis get to that point? I'm not sure. Because even even some of the latest Congress stuff that's going on with reconciliation bills and whatnot, they only mention, I think, Artemis 4 and 5. They don't even try to go anywhere beyond Artemis 5 in terms of giving money to the program and everything, and trying to secure contracts later on, right? And so I'm not so sure we're gonna get to Artemis 9. Again, I wish, right, that was the case, because then it will mean some greater things will be happening that means it's being kept around. But unfortunately,
Yeah. But again, we'll see. You never know at this point. And again, it will be cool to actually see this fly. It will be very cool to see this tested. That is for sure today. So a lot of excitement to come. Excitement guaranteed, I guess. And a reminder, if you have questions, you can tag us at NASASpaceflight, and we will do our best to answer as many of them as we can. Here's a couple questions I'm gonna kind of merge in together. Saj is asking, how many or why the switch over to carbon composites for the BOLE boosters, and then Lunar adding, has an SRB with carbon fiber casings ever flown?
I believe yes, but not segmented, if I'm not mistaken. That's sort of the difference there. There's also like all other types of casings as well that we've seen, for example, the gem motors, right? That also use that sort of thing. And that's one of the things as well, that the steel casings were a lot heavier. When you think about upgrading performance of a rocket, right? You think things about making the structure lighter so that you can still that ratio between the full rocket being fully fueled and the empty mass, you're carrying less dead mass, so to speak, right? It's sort of that thing of the less useless mass that you're carrying around, it means you can push the actual useful mass into space. And so you go from steel casing, which is very heavy, a lot denser. You have now carbon fiber. It's a lot lighter. You can essentially carry more performance. There's a lot of other improvements as well that also improve the performance and whatnot. But one of them, that carbon fiber casing, is definitely one of the things that you would essentially do to any rocket where you're trying to like optimize their performance. Of course, there's other things out there, other rockets out there that are using steel, but their sort of optimum is not about the performance, but things like reusability and things like that, right? Here, that's not the case in the case of these SRBs, and so you optimize things like, again, that dry mass, that dead mass that you leave behind. The less that you leave behind, it means it's not useless mass that you're pushing up into space. So you give more oomph to the useful mass.
Yeah, I mean, I believe that there are carbon fiber ones already. If I remember rightly, the ones on Vega C and now on Ariane 6 are also carbon fiber, but those are single pieces. It's a monolithic,
Yeah.
so unlike the segmented ones that we see here. A simple question, but still an important question. He's saying, what does NET mean? That is the no earlier than time to when we expect this firing to happen. So the last that we had heard was that they were aiming for 11:30 Mountain Time, which is 1:30 Eastern. So as you see there, about 20 minutes and 20 seconds from now, as we get to the best vet. Oh wait, wrong rocket. Um, but it is worth noting that we could still see that there's cars in the area, and apparently hearing from the people that are there that there are still people working around the booster. So again, that is also the significance of the no earlier than point, because it certainly can be later than the time that we have there. But we're keeping an eye on the timing, keeping an eye on the testing, and we'll update you as we learn more, including the fact that this very second we just learned more. We're now hearing that the delay is to noon local time, so that is 2 p.m. Eastern time, or about 49 minutes from now. So there's your answer with the people still on the pad. They're continuing to push a little bit further. It's not like it's a launch where there's a window because they have to worry about aircraft or anything in the area. So there's not really a window to worry about, but they are going to push a little bit further into their testing here today. So 49 minutes, 10 seconds to go. The clock there now updated. Let's see here. Some questions coming from you guys. Tushal with an interesting question, which I like, saying, why are they doing SRB testing? Isn't this a one-time use before they have to dismantle it? Testing these particular ones is confusing. I mean, Alex, part of it is just getting the data for the ones that they build going forward, right?
Yeah, that's one of the main things that they're doing here, right? They're trying to there've been some of these things that have been sort of tested separate. Like for example, they did a few years ago, if I'm not mistaken, a firing of just a single segment of these, for example, and they've done testing of many of these sort of different technologies and whatever, like like the electric TVC and whatnot. But this is the first time they're putting it all together, right? You wouldn't do that on an actual flight vehicle. You first want to do that on the ground, test that on the ground, and making sure that all of it works. And this is not even, the whole reason why it says up there on the bottom left, on the top left, BOLE DM1. The one is because there's going to be more in the future. Like there's going to be more demonstration motors, qualification motors. So there's a whole round of design and testing campaign that they're going to be doing in order to be able to get to the flight articles, in order to be able to eventually maybe put one of these on a launch pad. But that's one of the things that's pretty much still up in the air, whether they'll reach that point or not.
Well, no, it's on the ground right now. That's the important thing before it's in the air.
Exactly.
There we go. So, let's see what else we have going on here. I don't know if we have Philip still available in the field, because there's some good technical questions that I want to make sure we get answered there as well. So I'll wait till I get confirmation from our field team that we can go to them for some of the really cool techie questions that I have there as well.
And we're still here.
Oh, cool. Keiichi has a good question. They're wondering what kind of particles are they using for the propellant for this one? So what is the propellant they're using? Can you I know we talked about it briefly before, but can you kind of talk about the different shape that they use inside of it to throttle?
Yeah, I mean, it's I think the basic concept is that the more surface area you expose to burning, the more thrust that the solid produces. And so the 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 shuttle, the original 4-segment design had we talk about an 11-point star, or a 12-point star, or a 10-point star, and that's what you would see that if you were looking at a cross section of, if you were to slice the case across the diameter, you'd see that. But they're long fins essentially, and when they cast the propellant, they put these fins down at the bottom of and they cast the segments upside down, so the fins go at the bottom of the upside down case. And so for this one, there's only 10 of these, but of course they're all different sizes. And the idea is that these boosters, typically what you want is maximum thrust, either ignition or in that first 20 or 30 seconds of operation. And then those fins, as those fins burn out and that surface area is burned away, then you get this natural, the surface area essentially goes down. You get this natural, not quite as controlled throttle down as you would get with liquid engines, but that's how they control the thrust for these. And if you look at the center segments, the core that's the core hole in the middle of it is basically just a round circle. And then at the back end, you have a little bit of a different type of a shape because the combustion products are exiting the motor and the nozzle at that point. But that's the idea is that they all have different they all have slightly different shapes cast into them in order to control what they're calling the ballistics. And that's one of the major test objectives for this test is, since they're testing this for the first time in full scale, they have mathematical models that are predicting the thrust curve, thrust versus time. And they said, this is the first time we're firing it. It won't be exactly to the model, and that's the idea. Is you take the data from this operation and you put it back into the math models to better anchor them with real time data.
Yep. Again, that's why we test. That's exactly what the testing is for here.
Yep.
And Alex and I were just talking, by the way, Philip, about the carbon fiber composite material and everything as well with the exterior. UFO was saying if a small COPV tank can explode if it has small damage, how can this carbon composite SRB survive the heavy vibrations of being a solid rocket motor?
Well, I think I think all of these, all the different composite overwrapped designs, they all are, they all have different design objectives. I mean, they're, perhaps similar, but I would imagine that a high pressure gas bottle, which is has composite overwrap on it, is designed for, when you operate these things, like I'm speaking about SLS experience, they have similar overwrapped pressure vessels. They intentionally keep those at a lower pad pressure until they get right up until they're going to use them, and even things like core stage with helium, and there are other bottles throughout that vehicle. So those are not necessarily designed to be they're designed for that type of application where you're pressurizing them internally out. So if they're subjected to different types of loads, so obviously they would be these boosters are designed to handle ignition and combustion pressure in a very specific. The forces are applied in a very specific way, and then they're also designed to handle the in-flight dynamic loads that they're going to see until the vehicle gets out of the discernible atmosphere. If you apply different types of loads, even much weaker loads like a point load to these cases, or to a COPV, they can fail in maybe perhaps non-intuitive way. You would think, well, if I only apply 50 pounds of force here, that's nothing like 4,500 psi, the force that it's designed to handle, but it's designed to handle it in a very specific way. And so the way that you have quality control and you have processes for these boosters, so that they are not, so that you do not handle them or mishandle them or handle them in a way that they're not designed to be handled. So one of the things that they're getting ready to do here at Promontory is they're getting ready to do a hydrostatic burst test on a case as a part of this development campaign. And so, but that's the same thing. They're testing it where you internally pressurize the case from the inside out, and then for a burst test, you're going to take it up past its design spec because you want to see exactly where it would fail. But you're also not going to if there's an infamous case of shuttle solid rocket booster segments on a train that derailed, and fortunately those loads were okay. They inspected those cases and those booster segments, and they were okay. But it's still not the kind of thing that you want to play around with and try 2 or 3 times on them. Um, they're designed to be handled in a very specific way, and so that's, I mean, that's the as usual for me, a long-winded answer to that question.
That's okay. We've got Alex and Philip, so it gives me a chance to have a drink. I love it.
Yeah.
um, which apparently I'm going to need a drink because now I'm being told that I'm going to have to say BOLE 10 times fast. Is that what I'm seeing for the goal? Oh,
It
geez.
is. It is because you know.
Oh my gosh.
They were asking like what sort of goal we should put, and I said, let's make Sawyer say Bolly or whatever 10 times fast. I still don't. Philip, you need to help me here because you're way more into this than me. I've always heard like different pronunciations like Bole, Bolly, Bowl. Like what is it?
What is it? No, because well, it's Bole is how
Bole.
I hear it pronounced. So, and again, that might be one of those twisted American things where there's the whole Ole, which is how they pronounce that here. But I think that's I assume that's why they did that. That they're the engineer's version of being cheeky. But that's how I've heard it pronounced. I don't know, considering how bad I butcher Chinese spacecraft and launcher pronunciations, I certainly can't say anything bad. So, but I mean, it as I'm sure you guys have said a few times, and maybe not 10 times fast, but it stands for Booster Obsolescence and Life Extension. Again, and that's not one of the. I probably should ask why they went with that because it's sort of an umbrella thing. So like the flight support booster test they did here 3 years ago. One of the things they were testing in that was the motor ignition. So the igniter for the boosters has a safe and arm
Mhm.
device, which is sort of the last line of defense for you don't want this to start until you're absolutely ready to do it. And so, like in the countdown, I can't remember what they say. They used to in shuttle, like you would hear Hugh Harris or one of the launch commentators say, I think it was around 5 minutes or so, that the safe and arm devices are enabled, and that's very close to liftoff. But they're testing. They were testing on the current 5-segment boosters. The safe and arm device uses, again, these are shuttle heritage, 1980s heritage hardware. Those are obsolete, and they can't, they don't have suppliers that can supply those electronics anymore. So they had to start qualifying new new parts, new materials for things like environmental control regulations. And so this is this umbrella program where they have started testing some of the hardware that they're going to cut into the 5-segment booster design now and going forward through flight set 8. But then one of the things they said in the briefing was they're using that same ignition safe and arm device design for these BOLE boosters.
Yeah, makes sense. Test the new stuff on the new hardware. But yeah, it was one of those things that we hear all the time, and it's like, which is the correct pronunciation?
Right.
So I guess it's gonna
I'm
be
not sure.
Bole.
Like, I'm not sure there is a correct pronunciation. So,
Yeah.
but yeah, I've just heard it pronounced BOLE. I guess considering that it's not very well known, that most of the people I've heard it pronouncing it were, either NASA or Northrop Grumman. So, I guess we could say that's the way they pronounce it.
Well, Sawyer, you know the drill. You're gonna have to say that 10 times fast if we hit the goal.
Jeez. I'm probably going to embarrass myself somehow and flip up and say something stupid, aren't I? Like a day turning into more day again. Um, my God, how are we already halfway there? No, stop, please, no. Space Pope saying bless this test, and then also saying Pope is go, and then
Well,
another
but
one saying
that was necessary, right? We needed the go no go from the Pope, right?
I mean, yes, that is true. Space Pope
Yeah.
also saying "BOLE." Yeah, really, just trying to push me to say this, huh? Revhead with the 5 curly L's with pounds. Thank you for that. Space Pope also guacamole. I like that one a lot. Uh, and Oron Quake. Nope, haven't hit the goal yet. I'm not going to be saying your message. Good try though. Um, yeah, someone pointed out there will be white smoke regardless. That's what we're hoping for, at least. Um, Also of note, there is the Rocket Lab launch coming up in a short while out of Mahia. Just so you're aware, that is happening. We don't have any cameras there ourselves, so anything would have to be from Rocket Lab themselves on it. Although I do absolutely love the name of the mission. Get the Hawk out of here.
It is so much you, that name, Sawyer.
I really want to find out whoever named that mission and hug them.
I think you have like some far family member or something living there, working for Rocket Lab.
No, but I want them to be my family now. I appreciate them. It's so good. So as we wait for this test, we'll see if we can bring that in and have a little picture-in-picture as we wait for one big solid rocket booster to fire and one decent-sized Electron to fire. I guess
It's funny.
nice way to put it.
It's funny because an Electron is like the width, the diameter is like half the diameter of one of those solar rocket boosters. That's how big this solar rocket booster is.
I was about to ask.
Yeah.
Also saw a question with the SRBs here. It may be worth going through the quick history. They're saying, so Morton Thiokol back making SRBs. It's Utah and they were purchased by Northrop Grumman. I mean, how many different names have we gone through here, right? There was it Thiokol, then Morton Thiokol, then ATK, then Orbital ATK, and then
And ATK was like from Allegiant Tech Systems or something like that. Like at some point there was like another one in between as well, and then they turned into ATK.
Yeah, ATK, Orbital ATK, and then Northrop Grumman. I think that's how we got to where and here we are today. Let's see. We were talking about the fact that it is much bigger than Rocket Labs. I mean, this thing is pretty big. It's even honestly bigger than the shuttle SRB ones. Worth pointing out. We'll go into the size difference in just a second here. You can see there is the Rocket Lab stream on the left side for Get the Hawk Out of Here going on. Before that happens, Philip, I believe we have another update.
Yeah, sorry, we're trying to keep the PA muted, but hear what they're saying. But I think we just heard that they're now the new target test time is 12:25. Right.
9, 8,
Okay.
7, 6.
So the new targeted test time is 12:25 p.m. Mountain. So what is that? 2:25 p.m. Eastern.
Liftoff.
So that's another 25 minutes on top of the last time we heard.
Yep, so we'll wait to see the solid rocket booster ignite as we see Electron ignite on the left side of your screen there.
Aye.
At least something's flying on the screen, right?
That's true.
By the way, that is it's called Get the Hawk Out of There because that is for the Hawkeye 360 system that they've contracted. They've launched a couple satellites for them
and the
already.
Hawk is out of here for Electron's 67th launch.
Yep.
And the Hawk is out of here. It makes it even much better with the Kiwi accent. Just saying.
Yeah, as Jay was saying in the back channel, we don't want the thing on the right to fly.
That is very true. Yes, as we've talked about, that is secured into the ground quite well. I've kind of gone into details a little bit about it, but Philip, being there, maybe you have a bit more info on exactly how it's secured, the concrete that it's on. How is this thing not going to lift off when it fires?
Well, I mean, it's not it if it were not secured very well the way that the way that it is currently clamped, it's not going to go up right away. It's going to go. This is a horizontal test, and so, um, but I mean, as you were saying earlier, there is no, the solid rocket booster is 5 motor segments plus, and plus all of the core stage attached hardware, the aft skirt, which this test has. But then there's also a forward assembly which has got avionics, and then there's a nose cone. Well, this does not have a forward assembly. The avionics are basically housed in the test bay, but you have the front of the motor is bolted into that concrete block, like you said, and you just have this. You have these large struts, and I don't know how many. That's a several point star itself that are that converge on a point in the concrete block, and then you also have all of the um, you have all of the I think it's secure. I'm not sure where it's secured at the bottom, but like one of the things that they have attached to several points along the length of the booster is because they're not designed to. It'll the longer that it's lying there on its side like this, you'll get propellant slumping with that too. So they have they're not like saddle carriers, but there's some equipment there that's holding the booster to keep not just to keep it upright, but also to secure it to the ground.
There we go. Yeah, I knew you being out there would have the answer and the details for all that. Thank you, Philip. So as you can see again on the left there, we had the stage separation and ignition of the upper stage engine. Uh, so there you go, Electron continuing its thing. Now, Alex, you were doing some interesting calculations here with the measurements of Electron versus the
Set
BOLE
up the
booster on
countdown
the
clock.
right.
Yeah, because we got the numbers from Northrop Grumman about the BOLE dimensions. They are in imperial, so I translated them into metric. It's 3.77 meters in diameter by 47.5 meters in length. That's the BOLE. And Electron is 1.2 meters in diameter by 18 meters in length, which means the BOLE booster is 3.14 times wider than Electron and 2.6 times longer than Electron. I should mention that width is pi times Electron.
Yeah.
So BOLE is pi times Electron, I guess. Yeah.
Pi times?
Pi times.
There we
yeah,
go.
it's the. I mean, well, pi squared is also close to g. So g the acceleration of gravity. But yeah. It's a neat trick that if you're in physics, you usually substitute pi squared by g. But anyways.
Yeah, something like that. But yeah, keep in mind also that this is just the solid rocket booster. You also don't see the cone, the nose cone on the top of it too, and that's going to be attached to the side of the center core
stage
of the core stage. Yeah, that doesn't count the upper stage as well. Just for how big SLS is, how big this booster is, and how small Electron is. Small but mighty.
Yeah.
Oh my gosh, what am I seeing? What I think I'm seeing here? RC Horseman saying like a footy ball, a chant, bole, bole, bole.
Someone made a really good argument in chat that BOLE is as wide as the circumference of Electron because it's pi times the diameter, and pi times the diameter is the circumference. Anyways, too much math here for NSF.
You're telling me, my head's spinning already. Space Pope, space be with you. RC Horseman, here's another one. We're at 9. 'Tis me saying sorry, not sorry. Yeah, right. Space Pope, 10, and then RC Horseman saying over the top. Oh my gosh. I was so lucky. The first one, Max had, what was it? Jack had to deal with it. Then Adrian had to deal with it. Why me? Thanks,
Watch for
Kevin.
the-
Thanks, Jay. Thanks, Alex.
There they go. I was gonna say that they were about to jettison the batteries.
Battery hot swap on Electron, which I love that it is the electrical power on that one, which it's nice that finally the SRB is also going to be coming into sort of the electric age with the thrust vector control, finally away from the hydraulics, right?
Yeah, that's one of the nasty stuff that they have to deal now with the current SRBs. Because they need to load the hydrocene to be able to power the hydraulic system for that mechanism. But no longer is the case, at least with this new technology. Again, is it still the case with the flight articles, I guess? I should say, but yeah, not with the new stuff.
No, I'm not singing it, Kevin. No. It just said to say it 10 times fast. It did not say to sing it. Sorry. Too bad. Oh,
what
no.
if you do both? Sing
Oh,
it
no.
and
Don't tell
saying
me.
it 10 times fast.
Oh, jeez. No, Kevin! There's a new goal for the singing version. Never agreed to this. That was Jay? Jay, I thought you liked me. Well, you do? Really? That's how you say, hey, I like you. You're a good friend. I like working with you. Now sing a song that you have to make up on the fly using BOLE. Well, I mean, or should I say bully, 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 bully?
No. That doesn't count.
That was the 10 times fast one.
No, it doesn't.
What do you mean? I was told to say it 10 times fast. Is that not saying it 10 times fast?
No, you actually, because you were. No, that doesn't count.
No, I said the words. At
No,
least I tried.
That was too fast, right? Right, chat? You are agreeing with me?
You
That
said it
doesn't
was supposed to
count?
be fast. That was the goal.
But fast, and, we need to understand it. Otherwise, it doesn't count.
That was 10 and that was fast. Come on.
Some
See?
people say it doesn't count.
It was absolutely understandable. Anyway,
Kevin saying, I just rewound, it was only 9 ball.
I can count. Again, I went to school for journalism. I don't do math. But yeah, Rocket Lab there looks like getting into its successful parking orbit, and then we'll soon deploy the Hawkeye 360 satellite. So congratulations to Rocket Lab on a beautiful liftoff out of New Zealand. Which Jack is not in New Zealand this time. Jack is in Utah for the test that you see here. Oh gosh. Let's try and get to some questions, because all I keep seeing is more people trying to get me to sing stuff now. No. Let's see. Here's one from that I want to ask to Philip, if we have you back, Philip. I know it's a little noisy where you are. But I saw a question here regarding the igniters for it. So, where did it go? I promise I saw it here. Yeah, they were saying, so what are the igniter pyrotechnics like in the booster at liftoff? Do they simply just set fire to the grain? And what happens to them after ignition?
I mean, the igniter is essentially a yet another solid rocket booster in the that is on the booster. So you have the separation motors, which are again solid rocket motors. But the igniter is actually, I'm not sure we have the statistics on it, but it's essentially a solid rocket motor, and when it starts, it basically fires it fires down the length of the booster to start combustion of the exposed propellant. And I mean, it basically, that it was actually a good question about what the action time is on the igniter. It's probably not, it's probably relatively short, but that's the idea is that they designed this propellant so that it's, you still have to be obviously very careful when it's handled, but once it's cast, you really pretty much have to take like an open. This is what they were talking about on the tour yesterday. You pretty much have to take like an open flame to it in order to start combustion on it, and that's the igniter. The idea behind the igniter is to start combustion in as predictable a way as possible. So you want to get all of those for this design, you've got those 10 fins around the igniter area in the forward segment started. Want to get combustion started on all those, and then down the core of the rest of the segments towards the bottom.
And here's another really interesting question that I saw, Philip, that I'm actually curious about now, too. Ron Smith is wondering, how does BOLE compare to the old FWC SRBs meant for Slick 6 out in Vandenberg, the ones for when they were going to fly shuttle out of there?
That's a good question, which is kind of code for I'm not exactly sure. I mean, the composite fibers that are used for this. They actually talked about. I don't have my notes here, but they have apparently upgraded. They're going to upgrade from this motor to follow-on motors and into the flight design. And again, setting aside we won't necessarily know if and when this will fly, but um, they're continually trying to improve the producibility of these, and so this is a much different type of composite material. Same idea, but the same different type of composite material than the filament wound boosters that they started to develop for shuttle back in the sort of early to mid 80s. If I recall correctly, they did one test fire out here, um, and I think they did get as far as actually um, sending the first VLS-1 set out to Vandenberg, and they may have even stacked them, but I don't. That was as far as they got, and then they got destacked after 51L.
That would have been quite a sight to see out of Vandenberg to see shuttle fly from the Slick 6, which was the original plan. But yeah, it's a shame we didn't get to see it. Let's see here. Let me thank a couple more people. Flippers, I was peer pressured. You don't have to submit to peer pressure. If everyone told you to like Ares 1X, would you do it?
No, you're good.
No. Wait, what? Lord of Random saying, I gotta contribute, thanks. Sean plays too much, saying when BOLE heavy, or maybe Ares 3.14X. No, Ares, stay away. I hate that we have to keep bringing it up because of its relation to this. No. Matt's saying, bird is the word. Nope, that'll be another goal. Not singing that one. Sorry. Clinton Diaz saying, why not? Astro Knucklehead, come on, Alex, Spanish commentator. Goal!
But it's different. It's not the same.
How's it different?
Isn't BOLE and not bowl like is that what what I'm trying to imply here?
Plus, we've set a goal, or as all of the
True.
the commentators do. I don't know. I'm just a lowly American who doesn't know much about footy. Space Pope, please stop, Space Pope. No, you're gonna make me actually do this. Sawyer better put some wee woos in his song. You already have your song with my wee woo in it. That's enough. Also saying, I don't always make pasta, but when I do, I use BOLE. What? Is that a pasta brand I'm not aware of?
I think it's pasta bowl. I don't know. It's funny though.
I get you put like guacamole in a bowl, but I don't know. And then Clinton saying, have fun singing. Also, what's the current plan for SpaceX after Dragon ends? What vehicle will they use for private space stations? Alex?
They're gonna stick it on one of these bully SRBs. No, I'm
Oh.
joking. Can you imagine Ares 1 revived? No, but I mean, they're gonna be using Dragon as long as they have customers for it, right? Until Starship is up there in terms of reliability and human rating and whatnot. There's gonna be probably a lot of customers that are gonna be like, can we fly on Dragon, please? Right? It's gonna be a while until we see enough customers comfortable with moving to Starship. Doesn't mean there's no crazy enough people out there wanting to fly on Starship, right? We've seen that in the past, and we're still seeing it. That there's a bunch of people proposing flying on Starship themselves. But that's one of those things, right? That we really have to just wait and see what happens with that program. Yeah,
Right.
dear one.
Yeah, like we talked about with the Vast one, the plan is to start with Dragon, but eventually they do want to use Starship. And I think that's going to be the case for a lot of them. Also, I'm sure there'll be other companies that kind of jump in to try and, I guess, compete with them in that sense for stations. Like, I know we have Arianespace and Dream Chaser, which right now is in a cargo configuration, but there is still the potential for that to go into a crew configuration. So there's lots that could still happen, and I mean, Starliner exists. Take that as you will.
And
I
I
won't
mean,
say more on that.
if we're also considering Starliner, I guess it's a bit further out, but there's also Dream Chaser, right? It will be a whole different type of Dream Chaser, though. But Sierra Space has already told that they have the current Dream Chaser. I think it's the DC 100 series they're calling it, but then they have the DC 200 series, which will be both cargo and crew as well. It's like a larger version of the Dream Chaser, which would be able to support crew and things like that. And who knows? Maybe there are other companies out there working on their own human spaceflight programs. Blue Origin.
Oh yeah,
No.
no idea. Not like they have a lunar lander that works or anything either right now.
Yeah,
but,
right. Yeah.
But yeah, also the one interesting one with the 200 for Sierra Space is that if they did a crew variant, it was discussions of not having windows on it, but using monitors instead with live camera views. Just
I thought the DC 200 will be with proper windows because it's bigger.
Did they say that they were going to go for the proper windows now?
I thought I saw some of their. I mean, there's still renders, right? But I thought I saw at least the larger one was gonna have windows. Oh, I see, Philip. Okay, no, back to muted. I thought Philip was gonna say something. Sorry.
Well, I know Philip needs to head off for just a little bit as we approach 36 minutes till the test. Philip, thank you, and hopefully we'll chat with you again soon.
Yeah, Philip left, but you have me again if you want me.
Nah, I don't want you. Sorry, Jack. No, of course we do.
Oh, you're right. I'm looking now at the renders again, and yeah, the DC 200 also doesn't have any windows. They don't like windows. Why?
I don't know. They're probably Mac users.
Yeah, true.
Anyway,
Instead of laughing, I just kept going the joke. Anyways.
Yeah, thank you. Yes, it doesn't make it any less awkward. It makes it more awkward.
Someone saying, what does net stand? That's for no earlier than, right? We've had a few delays to that test time, right, Sawyer?
Exactly. Yeah, it was originally aiming for around I believe it was noon in the mountain time zone over there. and it's kind of delayed, or sorry, noon Eastern. Then it was delayed to one. Here,
Yeah, from
11
go.
to 11:30 to 12 to 12:25 Mountain Time. So add 2 hours for Eastern to each of those, or 6 hours for UTC. Again, numbers. I went to school for journalism, not math. I don't know, Jack, if you do have a second to chat. Just one thing we haven't even talked about is the environment. Where are you viewing this from? So, like, where is this camera positioned, and what even is the weather like out there right now, too? I don't know if we have Jack for that.
It's about 77 degrees. It's a little bit breezy, actually kind of cool out. I mean, it's warm. We're in the desert. It's hot. The sun, the UV. There's
Think
a
we
little
got
bit of
RoboJack.
high cloud coa, not without the humidity. And I'm about 1.4 miles away from the booster, the sort of media viewing location.
There we go. We got you back for the end there, so we heard that. All right, so about 1.4 miles away, and beautiful desert weather out there in Promontory, Utah, which there was a question from someone named Kevin Michael something. What was it?
Who's that?
Kevin Michael Book, Kevin Michael Twig. Oh no, Kevin Michael Reed. That's what it was.
Oh, I was going to
yeah.
say Kevin Michael illiterate.
Hey, Kevin Michael can't read. Saying, what is a promontory and why is it in Utah? So basically, it's in the Promontory Mountains is where that site is located. And so a high prominent ridge or a high point of land is called a promontory. So that is why it is called promontory in the Promontory Mountains in Promontory, Utah. So it's a geographical thing. And as Jack was pointing out earlier, also very historic for its role in the Transcontinental Railroad, where they put in the gold spike with the connecting the east and the west there. So basically, tall, pointy landform there. It was very prominent, so it's promontory. So it's promontory. Someone saying here, you
The
created
history
a
is
kind.
everywhere you look around here. You turn your head and there's more beautiful landscape or more history or like an old mine or something. Like Utah's cool.
I've never been to Utah. I need to be out there for one of these tests next time. Um, let's see. Fire Striker, you've created a kind of paradox. If the SRB is lit with another smaller SRB, how do they light the starter SRB with another even smaller SRB?
Smaller SRB.
Oh my god.
Yeah.
At the end, all you have is like a little firework that you just light with a match or something.
SRBs all the way down.
Oh jeez. Steven, thank you for becoming a Pad Rat member. Great time to be a member, especially with all of the behind the scenes happenings and things. I'm sure there will be some amazing photography and videography from the team out there that we will see on stream and some that we will see in the members sections here. So thank you. Space Pope, please, no. Saying let's go 10. I'm going to squash this goal. What is this? 12? Lucky number 13.
Oh dear.
This is all Space Pope, by the way.
Have they done this like for every single one of the goals? Oh my goodness.
CRE saying, I'm sorry, Sawyer, but it's your turn. Space Pope, I think I'm going to break you to billing. Clinton, I can't let Space Pope do this alone. And then Space Pope, I feel like I'm 15 again. No. I'm going to make you say the number 6 on air again now because of this. Thank you. That's what we really need. Jay is saying the number 6,666 would be very entertaining on air, would it not? Huh? Payback's a BOLE. For members who have heard him in the pre and post shows, he does say the number 6 in a very entertaining way with his accent. Yes, I'm aware that we can't say that because of potential demonetization with the pronunciation. Someone's saying that this is BOLE is launching from the Utah coast. Very clever. Again, this will not launch. It is worth noting. Hopefully, this doesn't launch, as Kevin has joked, as Jay has joked, as we have all joked at this point, because this will just be a test, a 127-second expected burn time test.
You joke, but Utah actually has a coastline, I guess, if you will, that they have big lakes there.
Yeah, a lake's not so much an ocean coast, I guess, but
well, it's salty, so at least
I'm
Salt
salty
Lake.
about this goal.
See?
Yes.
See what I mean there?
Yeah, it kind of smells like the ocean too.
Really?
There you go. There you go. Just splash down a starship there on the Salt Lake. Yeah, why not?
I mean, yeah, there is the Great Salt Lake out there, and Salt Lake City is out there in Utah. So I guess it's on a salt lake. No, Jay, I see it. No, I'm not. Not yet.
Oh dear. Are we gonna run the ticker, the breaking news ticker?
No, we better not. Because I do have actual questions that I still want to get answered here first before we do the singing, okay? Here's a unique question from Astro Greg, who's been a Capcom member for 32 months. They're saying, Alex, why are people still making toxic and expendable SRBs, old technology, when liquid propulsion development has skyrocketed, I'm guessing pun not intended, within the past decade?
Well, it's all about the power that you need, right? One of the things of the SRBs, we were talking about how it's 3.7 meters in diameter. I'm not sure we can find a 3.7 meter diameter booster at all, like liquid fuel booster out there with engines, even if you try to cram as many engines as you can, then has that kind of thrust, right? Like that kind of diameter, you can maybe fit like maybe 4, 5 Raptors, and it will still not get to the amount of thrust that you can get. And Raptor is one of the probably most densest liquid fuel engines that I've seen, because it's like, in the diameter of like if you were to fit in this sort of diameter, the amount of number of Raptors that you could in theory put, again, it's like maybe 3, 4, 5 tops, right, that you could fit in this sort of diameter. It will still be more powerful than, for example, the Atlas V with the 5 solar rocket motors. Like, it will still be quite a powerful rocket, but it will be not as powerful as this thing, right? When you need a lot of power, that's when you go to the solids, because certain rockets are not as powerful on their first stages. Like SLS, without the solar rocket boosters, will not lift off on its own with the only the 4 RS-25 engines, and so they need those 2 solar rocket boosters on the sides to be able to lift it off the ground. And the alternative, you could still get similar numbers of thrust, but then you will have a much bulkier rocket, or you will have to need more RS-25 engines, for example, on that core stage. It still will not match that sort of performance. So solids are good for that kind of application, where you just need a lot of thrust, very compact thrust, for maybe the first minute or 2 of the flight. And so, yeah. That's why they're still being made.
Exactly, because again, I know the point was about not having reusability with them, but you have the new ones that were built, the GEM 63XLs for Vulcan. You have them on Ariane 6. So there's still plenty of large rockets that need and use these solid rocket boosters. So yeah, it's one of those things where if it's so good that you can't beat it, you might as well use it. If they come up with
And
something better, then sure. But uh, the amount of thrust and the force that you're able to get from these solids can just be incomparable when you need that boost off of the pad.
yeah, and although the shuttle SRBs were reused, right? These for SLS are not being reused. And one of the things that I've always thought and that I've always, challenged is that view that, oh well, because the solar rocket boosters on shuttle were more refurbishable and like, they were dumped in salt water and whatever, like it was a lot harder, right? One of the things that was usually said was that it cost more to reuse them than to actually make them from scratch. Like the only advantage to actually reusing them is that you took a lot less time to reuse them than to making them from scratch. So even though they were more expensive reused, you could fly more of them, right? That's one of the benefits for the shuttle when they were reusing those. But I still challenge that view. I think if we got some kind of other company, trying to get any of this stuff optimized, like I'm sure there will be a way to make it also economical. Like, yeah. And probably at certain flight rates as well, it will probably become economical. But there's no company out there like that. So unfortunately, we're not going to see that.
Yeah, not yet. And again,
people asking you to sing.
jeez, Pat. Oh my gosh. Watch out, Jakey. Hi, Jake. Jake, you can sing for me. How about that? And he's gone. He doesn't want to sing either. All right, we'll go through the rest of these here. Space Pope, Sweet 16, FFC, Kerbunk Bunk, and then Mike Alpha Tango Sierra Mats with 20, and Anonymous. Let's hope that BOLE does not pull a ship 36. We do not want that. Hearing an update now that they are still on track for the current attempted time of this test, which would be 2:25 p.m. Eastern Time, which is 12:25 p.m. local time in Promontory, Utah. That's a little under 23 minutes from right now. So they are proceeding on time now with this current T0. Okay. How are we gonna do this? I guess I'll make up for the other one. I'll do a bit of a singing one with 10. All right. You wanted the footy chant? Bole, 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 bole,
No.
bole,
Bad.
bole, 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 bole. There's your 10. Okay, so we got that
Where's
one out
the
of the
goal
way.
though? Where's the goal?
I know. I'm just saying. I'm getting that first one out of the way.
Are we having music now by Jay?
Bole. We are gonna bole. We're gonna be eating guacamole.
Oh my goodness.
Bole, bole. Hey,
I have
what can
nothing
I say?
to do
The solid
with
rocket
this stream.
booster testing day for Bole. Hooray. Let's go. Thank you so much, Jay. You happy?
Oh, dear
Yeah,
Lord.
folks.
Somebody clip that.
Can we make a goal to stop Sawyer from singing? Hey, I wasn't the one that said I would sing. This was started without me even knowing. All of a sudden, I see new goal created. I even got the rhymes in there, okay? Oh my gosh. Yeah, now someone's got to clip that together with Jax and all of that. Yeah, thank you everyone with the stop singing. Please don't sing again. Really? Come on. I used to be I used to get paid to sing. I'm just saying that. So, and yeah, that was totally off the top of my head. Had no idea. So you're welcome. Anyway, no, I'm completely sober. I don't drink. No. Why is there another goal? No. Oh God, stop Sawyer from singing Bring Back Jack. Don't make me go a bole again, eh? I will. Now I will. Now I'm put bole. We are coming up on the 20-minute, 20-second not vent because this is a solid rocket motor. This is not a liquid booster. How does that work, Alex, then, in terms of pressurization and things like that? Is this pressurized, or basically how are they able to keep it kind of hanging out in the desert or hanging out stacked in the VAB for so long and still maintain integrity?
Well, it's a structural stable, right? It's not like, some kind of liquid fuel tank or like Centaur, for example, right? That needs pressurization. It's just structurally stable. One of the things that does happen though, when you have a solid rocket motor and you ignite it, that ignition keeps up the pressure inside. So, for example, this one is supposed to have a maximum operating pressure of around. Let me see. Hang on, because I need to. Because this whole thing is in. Okay, so I'm gonna tell you the Imperial. It's 1,330 pounds per square inch, but that will be around 92 bar, so roughly 92 times the atmospheric pressure. It's still quite a lot, but not a huge lot compared to other rocket engines that we know and love and everything. But it's quite a lot of pressure, of course, that this needs to hold once the motor is ignited.
Yeah, it's more the stability of it while it's burning than it is the stability of it on the ground.
Mm-hmm.
And that is one of the kind of benefits, in a way, of the solids, which another reason why they don't really go away is because they can last for a decent amount of time. I mean, we saw, though, with Artemis 1, there was concerns about the booster lifespan of being fully stacked and sitting out there, and they ended up rolling it back anyway because of weather. And while they were air, they were able to recertify them. But it's not so much that it was like, oh my gosh, it's degraded, we have to swap the whole thing out, right? It's kind of just recertifying that everything is still structurally sound.
Yeah, they have a lot of margins there when they do this kind of thing. It just has a lot of margin, as the structural margin is quite a lot. I mean, they spent what, 2 years since they first stood the solar rocket motors for Artemis 1, the aft segments on the mobile launcher. That does not start the clock, though. It's when they put the next ones on top. That happened like 2 months later. But still, 22 months. So yeah, that was a long time.
Right, and as we speak, the solid rocket boosters are stacked along with the core stage and most of the vehicle, actually, for
Yeah.
Artemis 2 inside the VAB at the Kennedy Space Center. Obviously, Orion is still not there, as it has its heat shield fun, but most of the rest of it is, so the clock is running for that, too.
Yep. Right now, preparing Orion for flight, getting all of the consumables and whatnot, and getting. I think they should be getting it out for the launch escape system installation soon, and so hopefully that'll happen. They also need to do like checkouts with the crew and everything. There's like I don't know if you've seen it. They do that also with Dragon, and well, they also did it with Shuttle back in the day, where they go, as the spacecraft is being readied for flight, the astronauts go on board and they actually test the actual vehicle that they're going to be flying on, instead of some kind of simulator on some 10 states to the west or something like that, right? And so that's going to be one of the other things as well that they're going to be doing, hopefully in the next few weeks. Hopefully for that one we don't have to wait a whole weekend.
Yeah, hopefully not. We'll see. Also, hopefully, once we do get the date, it goes and doesn't delay 5 more months.
Yeah.
Yeah, that was fun. Although, I will say, if it was not for the delay of Artemis 1, I would not be with NSF. So,
True.
that is one thing you can either thank or be angry at Artemis for delaying, is the fact that I'm here because of that. Because it was on the second, after the second delayed attempt, that I approached Chris Gebhardt and said, hey, is there any spot for me potentially at NSF? Mike Alpha Tango Sierra saying, wait, Jack is going to sing? I mean, when Jack comes back on comms,
No.
maybe? No?
No.
All right. I also didn't realize we had Jack back on comms here going on. So, as we are about 15 minutes away from the test, I saw a question asking, what substances are in SRBs that make them burn? Jack, do you have any idea what's inside this SRB, inside BOLE?
Funnily enough, the fuel is aluminum. But they're burning aluminum.
There you go. It's got that high specific impulse and thrust to weight's pretty good on it. If you want the official name for it, it's HTBP, which is hydroxyl terminated polybutadiene. But yeah, that's the simple version of it.
Yeah, I mean, of course, the solid motor is a mixture of the oxidizer and the fuel all together, plus a binder and a bunch of other stuff. So it's not just aluminum, but the fuel, the thing that's burning, is aluminum.
Yes, the
So,
forbidden
hang on.
peanut butter.
So this is burning aluminum, which means
Primary and secondary instrument
There-
room safety jumper indicates show in. Instrument room, have the arming crew install the instrument room fire line key and rotate to the closed position.
The fire line key is installed and rotated to the closed position.
The primary and secondary T97 key switch indicates show closed.
Arming preparations are complete.
Evacuate to T22.
Evacuating the instrument room.
See, the cars are now driving away from the pad area on the left side of the screen. As it sounds like we now have being able to listen into the comms loop from the test operators working this test today. And it sounds like the key is in, obviously not turned to the firing position yet, but the key is in, and now they're clearing out everyone away from it. Otherwise, those are going to be some nasty windshields that they would have to clean. Because it's worth noting, and this is something that anyone who's photographed an Atlas or shuttle can attest to, the output of these boosters, the residual from it, the residue, is quite tingly. Jack, I'm sure you've covered Atlas launches like that and had your remotes covered in the SRB crud, right?
Yeah, pro tip, don't touch your face after picking up your remote cameras on any launch that has solid motors involved, because you will have some residue on your fingers. And pardon the camera shake as I shim things to make them a little bit more stable.
Yeah, you definitely need to wear gloves when you go out to pick up the cameras, and then totally not take the gloves off and then go ahead and touch them again. No, I've never done that. So we'll keep listening into the calls as they happen. Astro Knucklehead, Canadian version now, please. BOLE A. BOLE A. We also had the Australian version. BOLE, 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 oi, oi, oi. John Diepper, thank you for coming a Red Team member. Bideford, good to see you, gifting 5 Red Team memberships. And I'd rather be flying an X-Wing, saying, since Alex was pushing you, it's his turn to sing. What you got, Alex?
No, it is. It is not my time at all. It is never my turn.
Oh, it will be.
I can make the joke that I was going to say before, which is, if they're oxidizing aluminum, does that mean that the exhaust is rust? Like, they're just doing the same thing that we have with our assets at Starbase and all the rust that they accumulate. But, like, in 2 minutes, right?
I mean, yeah, also you don't have to deal with the ocean breeze coming in and damaging things here in the middle of Utah.
Something, the Salt Lake kind of smells like the ocean.
Yeah, there you go. I mean, yeah, the lake is salt. I wonder if the Great Salt Lake is salty, right? One thing that we kind of talked about earlier on, but for people who might just be joining as we get into the under 11 minutes to go until this test, how does this solid rocket booster differ from what we're used to seeing for shuttle and what's kind of still being used now for Block 1 and 1B of Artemis?
Yeah, there's a few differences. So the main one that we have been talking about for pretty much the whole live stream, because it's most visible difference is the carbon composite casing, right? The older ones were made out of very heavy steel case, right? And so that means it's a lot less dead mass, so to speak, that you have to carry around that gets the performance up on the rocket engine as well, on the solar rocket boosters. There's another upgrade as well. For example, the gimbaling of the engine, that aft segment, instead of having hydrogen motors to drive hydraulics and everything, instead it just uses electric TVC, which is a lot less nasty, let's put it that way, because they need to load that hydrogen before every flight. And also another very important thing is the old solar rocket motors were built for the shuttle, right? And so when they cast the propellant and everything, it is also made for that thrust profile of the shuttle. Whereas now these are going to be made for the thrust profile that is needed for SLS, which means it's going to be a lot more optimized. It's going to have higher thrust of the pad, for example. It's going to have all of that, throttle down profile on the propellant cast and everything. It's going to be optimized for SLS, which means, it's a lot better in that case as well. It's also going to change as well the binding, as we're talking about. Instead of P-band, it's going to be HTPB, a whole long name, as we're also talking about. But yeah, lots of different little things here and there that overall bring up the performance 3 to 5 tons to translunar injection up for SLS. So that's going to be interesting if it ever flies. We'll see. But nonetheless, quite interesting technology.
It is. And speaking of interesting technology, Jack, I know you're working with a lot of cameras out there. I'm going to let you finish getting everything ready for the test, and we will talk with you after.
Thanks. I'll see you on the other side. Godspeed, BOLE DM1.
Godspeed, BOLE DM1, yes. But yeah, as you pointed out, the booster will be a lot lighter. The diameter is slightly different. It's a little bit bigger. Also, with a different diameter that's interesting is the nozzle at the bottom. And part of that, Alex, if I'm understanding correctly, is so that it mates better with Mobile Launcher 2 and with the Mobile Launcher platform that it sits on, that the nozzle can kind of just slide in easier, right?
Yeah, it's one of the other many upgrades, because again, the older SRBs, right, the ones that are still being used for SLS, they were made for the shuttle, and so they are not if you were to design SLS from scratch, this is sort of the solar rocket booster that you will use instead, where you have, again, higher performance. You're using newer technologies and newer propellant mixes and everything. And as you said, things like the nozzle and everything being more and the skirt adapted to the ML2, right? And so those things are the little things that again, if SLS had been made from scratch, that's the sort of thing that you work on. But they started making those SLS rockets precisely out of shuttle parts, except for the core stage, and so a lot of the things are essentially fitting things are not made for that type of rocket, trying to shoehorn that design, and so that's why you get a lot less performance right now with the current SLS. With all of these newer, like the upper stage, the exploration upper stage, and you get these upgraded solar rocket motors and boosters, so you get much more performance later down the line. A whole another consideration again is whether they're going to get to that point or not. We'll see.
Right. The plan is to start using these with Block 2, which is Artemis 9 and onwards. Right now, they are still in Block 1. Then next up will be the Block 1B, and that will be the one that will hopefully get humans onto the lunar surface for the first time since December of 1972. So, yeah. It might be a while before and if we see this. And it is also worth noting, as we kind of talked earlier, this is an evolution of boosters that they've already been working on for a different canceled rocket. Well, I should say a different rocket that was canceled, as SLS is not canceled at this point as we are live. There was the Omega rocket. There was Liberty, and then there was Omega. And Omega was going to be using these composite casings as well. And I believe they actually already did some testing with those cases, with the electric thrust vector control that we'll be seeing similar with this one.
Yeah, and that's one of the things that I also said in the back channel, that, you know, Omega, in my opinion, was better than Ares 1 in the sense that if you're going to make an all solid rocket, you know, kind of, because it was like the Ares 1 had the first stage as a solid rocket motor, and then you've got a liquid upper stage. It's like, at least put more solids onto it, right? Like, commit to the bid and have more solids. And so Omega was like a solid rocket first stage and a second stage, but also the first stage could also have solid rocket boosters as well. It was like, yeah, I heard you like solid, so I put a solid in your solid, right? It's sort of like that. It was committing to the bid. I think that's, you know, more, I don't know, I really like that better, that thought of, let's just go more boosters, more better.
It sounds like someone made that in Kerbal and said, let's actually try it. And I should say it's Omega, because it's capital O, capital A. Strangely with that
I wonder
name,
if they did that. I wonder if they did that because they were thinking of like Omega B, Omega C. I don't know, whatever.
OMG. Anyway, let me quickly thank some people here. I'm not sure I'm going to be able to pronounce this right. Vichahain, thank you for the €6 there. Space Pope, does this count as 2 for the goal? Guess I'll find out. I'll sing more if you need me to. JC Davis.
Support systems are go for static test.
Low speed systems are go.
High speed systems are go.
Ultrasonic data systems are go.
TVC systems are go.
High-speed video systems are go. Motor temperatures are go.
We are go for BOLE DM1 static test.
There we go. Sounds like they are go for the test. 3 minutes and 15 seconds-ish from now. Someone else is saying bole, if they pronounce it bala, is a Frisian word for bread. Wonder if we're making toast today. We'll certainly be making glass as it burns the sands here in Promontory, Utah. This is our NSF camera feed here from the test of the new DM1 booster for bole.
T-minus 3 minutes. Low-speed data operators, begin recording. High-speed data operators, at T-minus 70 seconds, begin recording and report at that time.
Roger.
All low-speed data systems are recording.
Roger.
There you go. The Booster Obsolescence Life Extension solid rocket booster that will be meant to fly for SLS Block 2. We'll continue to listen into the calls. And then also worth noting that once the firing does start, we are talking 127 seconds of expected burn time. We will let you listen in to the sounds of the mighty 5-segment SRB for the whole 2 minutes and 7 seconds. Let everyone enjoy the sound. Here's a view of that desert test stand there. And Alex, for those wondering why it's not white like we're normally used to seeing, those are painted, right? This is just the regular exposed copper.
T-minus 2
it's
minutes.
It's gonna be painted once it actually flies.
Exactly, and even potentially for future tests. So that is why it kind of looks like greenish colors because of the copper there that they use wrapped around it. And again, this is a special composite material rather than the steel that we're used to seeing for what we saw on Shuttle and the shuttle-derived hardware that they're still using currently for the
90 seconds.
Block 1. 90 seconds to go.
T-minus 80 seconds.
Test control coordinator, stand by to commit the motor.
Standing by. T-minus 70 seconds.
Commit the motor.
The motor is committed.
Under a minute now, hopefully.
60 seconds.
All high-speed systems are recording.
Roger.
Ultrasonic data system is recording.
Roger. T-minus 50 seconds.
TVC is go for static test.
Roger.
That's thrust vector control, steering.
T-minus 40 seconds. T-minus 30 seconds.
15 seconds from our view.
T-minus 20 seconds.
There'll be a slight delay between their feed and our feed, but here comes the firing and ignition.
T-minus 10.
Let's listen in.
T plus 10 seconds. T plus 20 seconds. T plus 30 seconds. T plus 40 seconds. T plus 50 seconds. T plus 60 seconds. T plus 70 seconds. T plus 80 seconds.
Central Support System Operator, enable the deluge, CO2, and quench tool controls.
Enabled.
T plus 90 seconds.
Open the accumulator enable valve.
Accumulators enabled.
T plus 100 seconds.
Activate aft deluge.
Activated.
T plus 110 seconds.
Activate forward deluge.
Activated.
T plus 120 seconds.
And there we go. The fire duration is complete, but it does look like there is an active fire still coming out of the booster there. Is the nozzle still there, Alex?
I'm right now looking at some of the views because it seems like as if the nozzle had an observation, if you will.
T plus 170 seconds.
It looks like though the
operators, stand by.
looks like the fire quenching system working there with the CO2 as well as the water deluge. To stop any remaining fires inside of the engine. Look at the fire on the mountains there too from that wide view. Going all the way up the side of the mountain, you could see some of the flames still from that. Holy smokes.
Huh. No pun intended, I guess.
Surprisingly, no, not intended originally.
But yeah, they have the CO2 suppression because, you know, once the SRB burns out, it's not like
High-speed
a
data
complete.
operators, stop recording.
There we go. It's not like a full complete burnout. Like, you know, the flame suddenly disappears. There's still some of it flaming out, and so that's why they have that system in place. But it also works when things like this happen, I guess, as you can see there. Although
Exactly.
those brush fires, probably gonna have to look at that.
Oh, definitely. Yeah, you could see it even in that view right there on the right. You can still see the fire burning there. The entire side of the mountain there also looks pitch black right now. Um,
Hmm.
Yeah, I mean, the rest of the booster is still intact. This isn't like a Rudd or a Ship 36 or anything like that, that's for sure. But look at the mountains of Promontory, Utah. The Promontory mountain range, quite toasty at the moment. I'm not sure. I don't recall. Does it normally get this fiery in the mountains? Alex, I'm trying to remember from the last booster test that we streamed.
I'm also trying to. I think for that one, it was also in July. Well, we're still technically in June, but it was like 3 years ago, July 2022, and yeah, I don't remember there being so many flames though. Maybe some other person that was there might be able to help with that. I don't know.
Yeah, Jack. First off, what was that like? And second off, do you remember seeing this much fire post on the mountain area after the last booster test you saw? I'm not sure if we have Jack back yet on comms. I know he's working a lot out there.
You're muted, by the way, Jack. If you're trying to talk, he said he's here, so I don't know. Okay, well.
Yeah, we'll give our field team more time because obviously there's a lot still happening right there. It's quite active. Boy, Jack and I need to stop being on streams together at this point. Too many observations. Well, that's going to affect the launch. No, I'm kidding. But that is quite a mountain fire there. Goodness. So how would this compare, let's say, to what we saw on Vulcan Flight 2, which that had an observation which the nose cone of that nozzle kind of liberated itself from the vehicle, as we can say. This seemed almost similar.
Yeah, it seemed pretty much like that. I'm not sure if this is like common thing or nothing or anything like that. I don't think they have stuff in common. But it is definitely one of those really hard things to do because remember, the nozzle is at the end of this big fiery stick, right? And it needs to also swivel, unlike the ones on Vulcan. The ones on Vulcan are fixed in place. So you have a very, very complicated place where, the nozzle also needs to swivel, but it also needs to protect and seal the end of the casing at the bottom of the solar rocket booster from, getting all of that combustion out of it from the sides. You want it out of the nozzle. You don't want it, that seal needs to be really, really good, right? And so it's a rather complicated, so it's not a surprise that, when you see some kind of issue with an SRB or just a solar rocket motor in general, it's usually around that part of the engine, right? It's because it's a really complicated place for that stuff. So yeah, it seemed like they may have had some issue. But remember, this is the first demonstration motor. There's gonna be more if gets funded, of course. But that's one of the things, right? This is why they test. We talked about this earlier in the stream where they have tested a lot of these components separately. This was the first time they did it together. You wouldn't do this straight away for the first time on an actual flight vehicle.
That is true. By the way, I thought I heard during the webcast about the time when that happened when we heard the countdown comms, the woman on stream go, "Whoa." And we're getting replays pulled up right now. But yeah, seeing some of the replays that are being worked on right now, it appears as if the woman did in fact say "whoa," and that the time coincides with the nozzle liberation. I'm trying to think what else to call it. Observation.
Observation.
I mean,
Yeah.
Jack and Sawyer, you two are here. When things unexpectedly happen, that's pretty much everyone's reactions, right? Whoa.
Hey, John Oliver,
Yes.
thanks for featuring us, huh?
Yeah, right? But yeah,
We're happy to commentate anything you want for us. Let's see here. Let's see. We have a clip of the moment of liberation from the NASA stream. So let's take a look. This was from the Marshall stream.
Activated.
Whoa! T plus 110 seconds.
Also a
The
reaction
whoa
as
and
well.
the gasp.
Deluge?
Yeah.
Yeah.
Activated.
Whoa! T plus 110 seconds.
Yeah, I think it's safe to say that's not nominal.
Yeah.
It appears we've had nozzle blew up. Look at the shockwave from it.
Wow.
You could see it into the flames there, that shockwave from it. Oh. And then, again, I'm sure that impacted the reason why we're seeing so many fires, because part of the goal of that is to kind of keep the thrust in a specific direction, right?
Yeah, that's one of the things, and it's way, way, way too early to say, oh, what will have happened if this was an SLS or something like that, right? Because I'm seeing already people asking about that. When it happened on Vulcan, well, fine, right? It's fine. It was fine. It was compensated by the B-force, but that's more or less what happens on that specific moment in that specific case, right? You are never guaranteed that if this were to happen, to another different rocket or another different place, like, in the case of Vulcan, they just had the very high luck that the nozzle, when it blew up, it did not damage, for example, one of the B4 engines on Vulcan. If that had happened, then we would not be talking about that as a successful recovery of an in-flight issue with an SRB nozzle, right? So who knows? Who knows? But yeah.
Yeah, one thing we do know, obviously, the smoke in the mountains of Utah after the test. It looks like there's already cars going out to the test site there. I think we saw some vehicles starting to pull into frame.
But also another.
Go ahead.
Oh, I was going to also mention that we're talking precisely about the TVC, the thrust vector control system on these boosters. That's one thing that the Vulcan does not have, right? The boosters on Vulcan are fixed in place, so those nozzles are there and they don't move. These do move, and they control the ascent portion of SLS. Now, granted, by 110 seconds into flight, it will be way downrange, right? So it will not be off the pad or anything like that. And actually, as we saw there, the motor was pretty much about to burn out already. If I think Philip said 127 seconds, right, was the burn duration. So it will have been not that early. It will have been a lot further into the flight.
But the problem being is that you still have that steering issue. So if it were on one of the two boosters, the other SRB would be pulling a lot of extra weight. And of course, you still have the RS-25s that will be doing their steering. So it's going to take all 5 of those to compensate. But with the SRBs, once it ignites, A, you can't turn it off, and B, you cannot change how much thrust is coming out other than what was already built into the pattern and the material that they used in the packing and of the ignition source there.
Yep.
All right, we've got some replays here. Let's take a look and see what we got. And the sound delay. And this is where we were getting some stills from Jack that we'll be able to see in a bit. Let's wait for the audio to come back in and take a look out now for the observation, as we call it. This is what goes on behind the scenes, by the way, when we're at these launches here. You can see there it is. Right there is the observation. And now you can see, here's the sound again. You can definitely see after the observation how much wider the spread was on that, and that's when you see the mountains starting to blacken. And again, on the right side of your screen is a live view of the burn that occurred from it. And on the left was the efforts to stop all of the fires afterwards from it. And again, that's one of those where even if there is an observation, the fact that it's it's a solid rocket motor, can't turn it off. So we knew it was a 127-second burn. No matter what, that was going to burn for 127 seconds. And it did, just in a bunch of different directions. So I guess it's worth noting what's next then, Alex, for BOLE. So what do we still have in the pipeline for it?
Well, first, they'll probably need to look at the data from this. They have also like design reviews and things like that they need to complete. I believe there's another demonstration motor as well, and later on there's also qualification motors that they'll need to test fire on the ground as well once the design is further advanced. But yeah, that's pretty much what is ahead of it. As we're mentioning, this is for SLS Block 2, so it will not be in any flight capacity, at least, until Artemis 9. That's when SLS Block 2 will be debuting in that case. So quite a long time to go for that.
Exactly. Boy, you can still see the smoke from that. That was quite a thing. We're also going to take a look at the NASA views in a moment as well as we work on pulling all the replays. In fact, here it is. So this was the view from the NASA feed, of which all the audio that we had for our stream was coming from Jack 1.4 miles away. I mean, Jack, if we have you back, the rumble, how was the rumble, my guy?
I couldn't tell you.
What?
I know that's like the worst answer. Dude, I was working. I'm sorry. Like, I really am. I was firing a slow-mo camera. I was making sure the stream camera was rolling. I was trying to also shoot stills with the stream camera, which is why you lost audio for a second. It was, it was very loud. It was very loud. The ground was shaking. It's very cool. If you asked me to compare it to a launch or something, I wouldn't be able to give you like an empirical how it felt versus a Falcon 9 or how it felt versus SLS or what have you. I'm sorry for that. But, eyewitness testimony is notoriously fallible.
That's our job, is to tell everyone how it was.
I mean, it was awesome. And you could definitely see in person while it was happening. You could observe the nozzle. It was very observable.
An observation, very observable.
Yeah. It was like one of those moments where you're like, oh, okay, make sure camera is rolling, kind of thing. Because you never know what's going to happen with a test like this. And just to be clear and to reiterate, in case you all haven't been, because I haven't been listening to comms, it's a cliche, yes, but this is why you test. This is the first test. That's why it's DM1 of this motor. And the entire point of this test is learning things so that they can then improve the design, make it more reliable, make it better, characterize it, and then hopefully maybe someday if SLS doesn't get canceled, buy it. So, interesting observation. I'm so freaking curious what my slow-mo caught. Stay tuned to NSF socials for the slow-mo. Also, if you're not subbed to the YouTube channel, you should probably do that because we're probably going to put out a video of all the different shots we were able to get. But yeah, I'm floored. I mean, I feel bad that they had an observation, but hopefully they got some really, really, really good data today that they can then use to inform the next test of this basically bleeding edge of technology, like bleeding edge design.
That is true. I mean, there's not that many solid rocket boosters to begin with, but then add in the ones that also have the carbon composite and that are segmented and are 5 segments, which is massive. So there's a lot that'll be coming out of this. Hopefully that's good. And as pointed out, this was just test number 1. Philip Sloss pointing out earlier, they still plan on doing a second test and then 2 additional firings, it sounds like, even after that. Let me quickly thank from earlier JC Davis saying, will Vulcan be the last living American rocket to use solids if SLS doesn't make it? I don't know if it'll be the last. I mean, I guess it depends on efficiency and reusability. Right now, though, Alex, I don't think there's any other U.S. rockets that are planning on using solids, right?
Yeah, I don't know which other rocket might be the one using that technology, but we'll see. You know, it's one of those things that you never know where it's coming from, right? Might be some other company out there. I do know, for example, hybrids are something that some other companies are trying to work with out there, not just in America, but also in Europe, in China, and things like that. So we'll see.
Indeed, we will see. Also, FFC, thank you, say Bole D, Bole Do, Bole Dum. And then James Neal saying during one of the photos that he was taking, you can see something happen before the main breakup. Yeah, you could see it a bit from Jack's replay there. You could also see it from the NASA replay. It looked like there almost started to be a burn through of the nozzle. You could see it starting to get bright up at the top there. Let's take one more look at the events that happened here. And we'll start to see the top kind of get a little roasty toasty. And as we watch this final, the replays here, I do want to thank everyone that joined. Jack, I know you're doing a lot out in the field, but thank you for rolling out and can't wait to see on all of our social channels, X, Facebook, Instagram, all of that, your amazing photos and videos.
Slayer, if I may wax poetic for a moment, this is like my very favorite type of thing to do for NSF. If you appreciate this type of content from NSF, please hit the like button and do all the YouTube things and consider buying some merch or supporting us in any way you see fit, because it takes a lot of money for not a lot of return to do something like this. We really truly care about covering all spaceflight activities from all companies and ideally all around the world. But we're not a big company. We're a small company. We're a group of ragtag individuals who know what they're doing and do what we can with a shoestring budget. And, to be able to come out here, to be able to expend the resources that I did to get 3-4 cameras set up as remotes and the stream camera, and to have Philip out here and Justin out here to do the reporter thing that I am just no good at. I'm good at pointing camera and pushing button. Like it's not trivial. Plus, everybody in the back channel, everybody running the stream. It takes a huge team of people. It's such a privilege and such an honor to be the tip of the spear out here in Utah, helping bring this coverage to everybody around the world. And I'll be frank, I'm just going to say it. We went on a factory tour yesterday. We got to see things very few people ever get to see. Do you know how many media were on our bus? It was like 5 people. It was a travesty. It's truly a travesty. The fact that we got to see and tour and learn about the bleeding edge of solid rocket motor technology, and the media can't even be bothered to show up. So the fact that we can do this, the fact that we can bring you guys these views means the world to me. And it's one of the things that I think is NSF superpower, is that we can roll out to the middle of nowhere, somehow get photons on the internet and broadcast around the world. And it's a really special thing. And I could not imagine anything better to be doing with my life. So I'm done. I'll shut up. I just want to say thank you once again to everybody out there that's watching. it really is truly a treat to be able to do this, and thank you for the support. If you like what you saw, comment on the video and just like to do all the things so we know, so the algorithm knows, because we want to do this more.
Snaps, everyone with the finger snaps in chat now as like a poetry thing.
I'm riding the adrenaline wave, can you tell?
No, not at all. It's a shockwave right now, it feels like. Alex, thank you for hopping on for commentary with me.
It's been a pleasure, and hopefully we get to see more exciting tests like this.
Thank you to Chris Bergen, who started things off here with the hosting, NSF official. If you want more of Chris and more of the Starbase stuff, we have our Raptor side chat that will be going on at Starbase Live at the top of the hour, I believe. So you can tune in and ask your Starship questions there. And when it comes to shuttle and SLS questions, we had Philip Sloss, who is the absolute expert here at NSF on all of that. So thank you to Philip Sloss. Thank you as well to... All right, I guess I'll thank the producer, even though you made me sing, Jay Keegan, pushing the buttons, pulling the levers today. Thank you very much for that. I am Sawyer Rosenstein. I've been your singing host. We will see you all for the next live stream. And head on over to Starbase Live, not only for 24/7 views, but chat about Starbase stuff. Have a good one, everybody.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, Atlantis.
Water towers fly! Yes!
Echo down to nominal. Flighting downside FD off. Bring in FD off. It's orange! 145! Oh my god! Oh my god! Decollage! What is it? Put that in the big bag,
343 unfolds to go. Indeed. We rise together, back to the moon and beyond.
The methane would be igniting in the flare, correct?